Gauri seems to be having problems.
He's connecting.
Thanks, Diego. We'll just wait a couple more minutes. Hey, Gauri.
Oh, I think people see us right on YouTube. Not sure they can hear us.
Hey, Gauri. Gaur, Sham and Ali, should I
Yeah,
start?
you are audible, but I think Gauri again disconnected.
Hi everyone, can you hear me?
Yeah.
All right. Salil, are we good to go?
Yep.
Salil, can you hear me?
Yeah.
Yes, sir.
Okay, so I will. I need permission to share my screen. The host should enable access. Okay, all right. Yeah, I'm good to go. Thank you.
We can see your screen, Gauri.
Gauri, do you want me to start? And then you can, I think you're muted.
Yeah.
Okay. Hello, everyone. Welcome. Good morning, good afternoon, good evening, wherever you are. So as one of the general chairs, my name is Salil Kanere. On behalf of myself and my co-general chair, Professor Bhaskar Krishnamachari, we would like to welcome you to this third edition of BlockSys, the international workshop on blockchain-enabled network sensor systems. So we've got a very interesting program. We'll be kicking off with this keynote shortly. And before we do that, I'll quickly pass on to Gauri, who's one of the program co-chairs, and he'll give you a very quick overview of the program. Then I'll introduce our keynote speaker, and then we'll get going with the talk. So over to you, Gauri. I don't think we can hear you, Gauri.
Can you hear me now?
Yes.
Okay, so what's happening is if I'm sharing my screen, for some reason it's... Can you hear me now?
Yeah.
All
Yes.
right, great. Okay, yeah, so thanks for the welcome remark, Salil. Yeah, I'll quickly go through the process that we have followed in the past few months to get to here. So as Salil mentioned, himself and Professor Bhaskar Krishnamachari are the general chairs for BlockSys this year. And myself, Gauri Ramachandran, and Ali Dori are the TPC chairs for this year. And we worked with some great colleagues to put together the program for this year. Special thanks to Shantanu Paul for gathering more eyeballs to our event this year. And he was aggressively announcing the event through various channels. And thanks to him, we were able to get more attention for this year's event. And we would also like to thank the TPC members for their contribution during the review process. And after the review process, in total, we accepted 5 submissions for publication, including invited papers. And some of the exciting topics or keywords for this year's program include lightweight consensus, and there is an interesting paper that talks about decentralized trust management for network systems. And there is also a paper that is in the context of 6G, and there's an interesting solution proposed for provisioning service for 6G networks in a decentralized fashion. And there's also a paper that is looking into the scalability of consortium blockchains for network systems. And the programs are already available at our workshop website. So we encourage you to go to the website to look at the program. And in terms of session arrangement, I'm assuming you're already following the workshop in the YouTube channel. But in addition to that, we are asking you to post your questions on Slack channel. Again, if you don't have access to the Slack channel, the information is available in the workshop website. So if you go there, we have given instructions on how you can get access to the Slack channel. So follow those instructions, but throughout the workshop, we are requesting you to post your questions on the Slack channel. With that, I will hand over to Salil to start the keynote session. Over to you, Salil.
Ready to
Thanks,
go?
Kavi. Yeah, Michelle, you can start sharing your slides and I can do a quick introduction. So it gives me a great pleasure to introduce our keynote speaker today, Michelle Nati, who's the head of telco and infrastructure development at IOTA Foundation. So Michelle has a very interesting background. Actually, he's worked in academia for quite some time, and now he's working in the industry. So we are hoping to learn a lot from his experiences. So Michelle received his PhD in computer science from the University of Rome, La Sapienza. He spent some time at the same university as a postdoc, then moved on to the University of Surrey, where he was a research fellow. Following that, he worked at Digital Catapult for a few years. And for a little over 3 years, he's now been working at IOTA Foundation. So we are really interested and keen to hear more about IOTA, some of the technology behind it, and also some interesting use cases. So please join me in welcoming Michelle. So over to you, Michelle. Thanks.
Thank you very much for the introduction. Indeed, yes, I've been involved in academia for quite some time and been also participating on the other side, submitting papers and presenting results of my research in workshop like this. And I'm very glad to be part of this one and to see that now blockchain and wireless sensor systems, IoT became a topic in itself inside a big conference like Sensys. So that's very interesting, and for the way ahead for distributed ledger technologies and blockchain. You had said already, my name is Michele Nati. I am head of telco infrastructure development for the IOTA Foundation. We'll see a bit better what is the IOTA Foundation and what is actually IOTA. And I'm actually very glad to speak about IOTA in the context of wireless sensor systems and IoT, especially why IOTA can be a real backbone for transaction, whether it's about IoT device, whether it's data, whether it's assets as well, that can be connected to wireless systems in the future metaverse. What IOTA can do and how IOTA is a good technology for this. Analyzing some of the technology background and the use case, we are currently working in this domain, but many other are also present on our communication channels. I'm going to present how IOTA is today. So if you are following the technology, you know that many things are coming, many things are changing, new things and new solution will be deployed on the main IOTA infrastructure, the main ledger network. But as it stands now, and as a good starting point for research and start to combine research with IOTA, I think that's the starting point for many that just start to know about the technology. So let's dive into that. I plan to speak for an hour. If I'm too long, please stop me, and I'm happy to have some question at the end. So I'm gonna go with a brief introduction on what is IOTA and why IOTA actually is needed, why IOTA is not actually a blockchain, but a distributed ledger technology. So we know that most of the people are familiar with blockchain, distributed ledger as subcategory, actually a bigger category of what blockchain are. Same properties, some advantages depending on the flavor that you use, but it's not really a blockchain. Distributed ledger is something bigger than blockchains. IOTA as a protocol, I will explain a bit the protocol, how the consensus work, and as well how the governance of a network like IOTA, which is decentralized, works. And when I talk about adoption, I mean how IOTA has been currently used in the industry or research topic as a broader area. So first of all, why IOTA? So we started some time ago having in mind that there is a need of a blockchain that is not only good for supporting monetary transaction, value transaction, exchange of new money, cryptocurrency, especially for those that are not able to access service from banking systems. That was the initial idea of blockchain. So, but this brought to designing a system that worked very well for that specific scenario, although we know now there are some challenge with the fees and the volatility of the token and so on and so forth, for which basically the technology became as a way to store value rather than to transfer value. But that technology back then wasn't available to support a vision where there should be a decentralized way of device and things to communicate without central authority, without central point of failure, that allow to be the backbone of all the Internet of Things communications. But for doing this, we need to basically satisfy the properties that blockchain didn't really satisfy in this flavor back then. First of all, is of course guaranteeing trust in data. So the data are important as the service that are exchanged in IoT networks, but the data need to be trusted. So there needs to be a way to guarantee integrity. So the blockchain should be there not only to support value transaction, not only to support exchange of value, so be the enabler for something that has a value attached, but also data. And data sometimes don't have a value, or sometimes have a very little value that cannot cope with the cost of using an infrastructure like blockchain. Of course, need to be fast. We know that existing blockchain have some limitation, so that the ledger that want to support this vision of sharing data for the Internet of Things should be fast, should be able to scale with the envisioned scaling of IoT and data that we foresee from now in the next 10, 15, 20 years. And as well should be able, this technology to guarantee end-to-end security to every device connected, so every device can be part of the network. So the consensus algorithm should be also lightweight, as well as the client that allow different devices to connect to the network should be lightweight, should be able to connect any sort of device, run even on an IoT device. So the cryptography associated to that should be still secure, but manageable by this device. Having this in mind, and this end goal of having this decentralized infrastructure, the quest was for identifying, is it possible to do this with blockchains, or we need a new different technology? And as it was now, and it's even more, it was back then and it's even more now, blockchain has some problem in this direction. It's very good, as I said, especially if you consider Ethereum or you consider Bitcoin to somehow secure value due to the volatility and the high raise of the token, but it's not an infrastructure that can be used every day. So, and the main reason is because there are fees. You all know, and assuming you know, I'm not going into the detail now, blockchain works now, but you know that blockchain have a hierarchical structure where you have some super nodes that maintain the ledger status, maintain the consensus of the network, that have to be incentivized in their work. These nodes are called miners, and to incentivize their work, there is reward for the work that they do, and there is also incentivization that comes with a fee structure that is requested every time somebody wants to push a transaction into the ledger. In this case, whether it's a Bitcoin transaction, whether it's an Ethereum transaction or it's an Ethereum smart contract, you always have to incentivize even more the work of this miner. This because, like I said, is a hierarchical infrastructure, so where some nodes are more powerful than others, and put more resources into keeping the network secure, but they are at the same time a scarce resource. Not everybody can provide that kind of infrastructure. Node infrastructure is required to the whole network to run. So in principle, what you have here is the problem that many want to use the blockchain for transferring value in this case, but the resources available to keep the network in a valid state are limited. So there is a competition between transactions that arrive to the network that have to be processed and those that actually goes on top of the queue and are processed in each time frame. So for incentivizing this, for speeding up this process, you need to add fees. And the fee structure works very well when you're talking about value, when you're talking about transferring value between wallets. So you already have a value that is being processed by the network. So adding a fee, it's always a percentage of this value. And usually the higher the value, the lower the percentage that you spend in fee. And this is a convenient transaction from everybody. You always know that if you want to transfer value, you have fees. The more you transfer, the less the fee impact your transfer. So it's good. But if you go back now to the initial vision that I said, how we can support now transferring of data that might have even zero value or very little value. So we know that IoT data especially are good when they are combined. The single piece of data of a data time series doesn't have much value. So you can't expect to put an incentive too high to secure this data into the ledger, into the blockchain in this case. So for scenarios like this, value-driven, let's say, or value-focused network like blockchain with this hierarchical structure, with the fee structure, doesn't really work for this ambition. So this is the first bottleneck that we start to see in blockchain and traditional blockchain. And of course, like I said, this creates a bottleneck in terms of transaction, in terms of priority of who access the network, and create some kind of divide. So those that are willing to put higher fees because they're moving higher value, they might go ahead, and other that use the network only for little value, or they can't afford to put too much value in their transaction, especially if you're talking again about data, they probably will be stuck before using the network. So that's creates some kind of divide other than a bottleneck. And most of this comes from the way I explained before the blockchain works, most of them, and the fact that there is a linear processing of transaction in order to create this famous block that create a chain of blocks. Every 10 minutes in the blockchain, for instance, a block is mined with valid transaction. And this is all, let's say, a sort of friction that is put into the network to guarantee the security of the network. So wasn't good for the vision initially that moved IOTA and IOTA Foundation to propose a new protocol. So what was the option? The option was, let's try to find, let's say, flatter, let's say, hierarchy, a way of processing the transactions, and as well achieving consensus on valid transaction. When I say achieving consensus, I assume you know that the main reason for a blockchain to achieve consensus on valid transactions is to avoid double spending. So because we are talking here about digital currency, crypto token that can be eventually created out of thin air, you don't want that a holder of some token can spend this token into different transactions, creating a double spending. So that's the main problem of achieving consensus in a blockchain or a distributed ledger. So the idea moving forward from IOTA was, let's remove this hierarchical structure, let's remove this need of super nodes that create conflict and create competition into the network with something that is a bit more homogeneous, democratic, and every node can do a part of the job in validating transactions. So we don't have anymore that bottleneck. So we moved from a chain of blocks structure to a more distributed structure, which is a direct acyclic graph, which is called DAG in short, in mathematical terms, but in our case, it's called Tangle. Our specific direct acyclic graph is called Tangle. You will see why later. So the main idea was, let's try to move from sequential work done by only some nodes that create this bottleneck to a more distributed way of working and a parallel way of working where different nodes can do the same job at the same time. So that's the idea behind IOTA, and that's why we don't call this anymore. There are other reasons, but blockchain, but call a distributed ledger technology, because in the end we will see that we guarantee the same properties, but we achieve consensus in a different way, and we gain some of the benefits of not involving incentives, not involving supernodes like miners, and so on and so forth. To do that, there is a need for three elements. Like I said, there is an element of basically the technology, having the technology that works. There's an element of maintaining and keep developing this technology. We know that real world is not exactly the same of the mathematical work. So where things work on paper, mathematical proof, then you need to be able to understand and keep track of how things behave in real world, and when you also discover new sort of attack that are possible, thanks also to new resources that are available, hardware cost goes down, risk of attack goes up, quantum computing is coming. So all of these need to have an organization around that, which is the IOTA Foundation I will talk about, to maintain an oversight on what's going on, maintain the protocol always up to date. And of course, help to generate, like I'm doing here, like we do in the foundation, adoption from the ecosystem, support third party that want to develop, and having at the core of this adoption with the ecosystem, keeping the technology always free, open source, and accessible to everybody. These are the three elements that characterize the vision of the IOTA Foundation, the IOTA protocol itself. So going now a bit fast into how IOTA works, we understand that it's not a blockchain, and we understand that try to bring some of the benefit of blockchain, like secure data transfer, forward to new use cases. It still achieve new benefits like highly scalable number of transactions. So the way we'll see IOTA works now, and even more in the future with other updates we are doing to the protocol, guarantee high scalability, the scalability of transaction that we need for Internet of Things transactions, whether it's data exchange, whether it's paying for a service, for a sensor node, and so on and so forth. But still with a very unique selling point, that is the zero fee structure. So every new transaction that arrives to the network has the same right to be processed of any other transaction. There is no need to incentivize the processing of the transaction by adding fee. So IOTA remain a zero fee ledger. So where, if you're talking now about value, you can transfer 1 IOTA and receive 1 IOTA. There is nothing that you need to now think about. Is it convenient for me to exchange a value that is not too big if I don't, because I have to add fees? There is no more this need. So you can transfer any value, you will receive any value. You can even not transfer value, but you can also just use the ledger to immutably secure a chunk of data, portion of data into the ledger, and replicate this across the whole network without adding any fee. Something that is not possible with traditional blockchain. And of course, you start to see how the ledger, the DAG, we call Tangle, because it's a quite entangled structure. So as it grows over time, and there is no more that linear sequence of blocks that you can see in the blockchain. You might have some fork, but then all will be recombined with the 6-block rule. So in a IOTA and the Tangle, you find more this Tangle structure rather than that linear structure. But this has some advantages that I'm going to explain now. So like I said before, we have a DLT that have to support data and value transaction, we have to create a network where there are nodes that are normal computer, not super powerful computer that run the IOTA network. They maintain the ledger and maintain the security of the ledger. The nodes maintain actually a real database, time database of the distributed ledger, and knows what transaction should stay there that are legit transaction, and those that are actually violating the rule of non-double spending that should be removed. On the same time, we have nodes that can, like I said, process transaction from clients that hold a wallet. So if you want to transfer value, the client will hold this wallet and transfer value through the nodes that they connect, and they will maintain the ledger all in order way and in consistent way. Of course, you can also, as a client, connect to the network and send data or just check the ledger status. On the other side, the nodes maintain the ledger, and for doing this, perform some functionality. A very simple proof of work, which is not the proof of work using the other proof of work based consensus algorithm. Proof of work is only to in IOTA to limit the risk of spam attack, denial of service attack, and other sort of attack that can be generated if somebody has direct access, zero friction to the ledger. So the proof of work is used like in the email system. If you want to know that somebody is not sending a spam email, mass email to everybody, there are spam filters that check if the proof of work has been attached to the mail. There's very little proof of work done on a very little part of the mail. Guarantee that who is sending the information has to do some little, the mail in this case has to do some little work to that. So it's probably want to you receive this email instead of being filtered and classified as spam. So that's the very simple use of proof of work in IOTA. Plus they do a few other things that I will explain now, maintain the ledger status and consistency. Like I said before, it's a bit of repetition. So we move from a chain of block to a direct LCD graph that doesn't have any more special nodes. So let's see a bit how this works in practice. So you have to imagine that we are now having a look to a snapshot of the network, a snapshot of the DAG. So you start to see here the DAG structure already, so the direct LCD graph. A direct LCD graph, like I said, it's a graph which has a first vertex, which we call in this case Genesis transaction, and then is basically represent the first transaction that have all the IOTA token that has been generated at the Genesis, at the creation of the IOTA network. This first node then start to connect to any other different vertex through some edges. And all the vertex that connect to the Genesis are basically those wallets that at the beginning of the IOTA network receive basically token from the Genesis. This represent address that receive token from the Genesis. And the edge is basically representing how that transaction receive those amount of token. So basically that edge mark the transaction that went from the Genesis back to the first wallet or address owning those portion of token. And there will be many, there will be a first layer. So if you start to now think about that, starting sometimes in the past, then you start to see all sorts of transactions that link in this structure that you see here, where a portion of token has been distributed all over the network and so on and so forth. And you get to now a picture of the DAG, a direct LCD graph, in a specific time. So now what we have to do, what we have to guarantee, that basically those transactions that already exist in the network, they never violated the rule of double spending. So this is, like I said, is the first rule of having a blockchain or a distributed ledger that is able to work in a centralized way. If the nodes that participate to the network are able to maintain this rule, when we think about exchanging value between wallets, cryptocurrency between wallets, then the ledger can be used for many other things like just storing data and make data immutable. So that's why every ledger or every blockchain, the theory starts from guaranteeing the guaranteeing the resolution of double spending problem in a decentralized context without central authorities. So how IOTA and the Tangle does this? So if you imagine now the snapshot that we have of the network of the DAG at this time. So what you can imagine is basically that new transactions like this one that we call tip and reference transactions arrive to the network. And there are already the transactions that exist in the network with different degree of confidence. When I say confidence, I mean there is a different degree or assumption that basically these transactions are actually valid. They never violate the double spending issue. These have a lower confidence, and these still have to be defined because they're new transactions. So all of these allow the network to work and achieve consensus. Basically, what you have to do, it's a collaborative work. So when new node, and of course, you can imagine that these, some of them are 100% confidence because they are those that are closer to the genesis. So they have received the first amount of token, which are iota finite number of token distributed by the genesis. So those are very easy to track and say there is no double spending. And this way propagates up to the new transaction. When you have new transaction, basically what you do as a node, like I said before, that receive transaction from a client, you basically have to decide your reference transaction to which of the existing transaction they will have to connect. And for doing this, what you do is basically you have your ledger, and the ledger is actually a graph, so you can read the structure of this graph. Each node can do that, and basically you can see where the genesis start, what are the different transactions going out from the genesis, and so on and so forth. So what it basically does, each node when receiving a new transaction, it does a random walk from the genesis along this graph back to one node, back to one transaction here, where there is no entry reference transaction. When you find this, you decide, okay, my tip, the transaction that I receive, I have to process, attach here. And then it does this twice. Every time as a ledger, as a node that holds the ledger, I receive a transaction that is called tip, and I have to attach to the tangle, to the DAG. I need to go back from the genesis, traverse the structure of the graph until I find something that doesn't have any entry point, and again find another place where to connect my tip. The random walk is pretty random. So when you go, let's assume that from the genesis I walk until here. So now I have to decide. There is basically, the simple rule is just to say I go left or right. In this case, or you can decide to go based on the number of basically entering edges into each node. So basically you want to give priority to those edges that have been traversed, those transactions that have been traversed less time. So in order to balance a bit the structure of the ledger. So there are different, and there are different ways to do that, but the ultimate goal is actually to understand the new transaction, the tip, where it should connect to the network. So when you have done that to the network of transaction, when you have done that, there is one more job that you have to do. Basically, the job that you have to do is you identify a path now that goes from the genesis backwards to one and the other transaction where the new one attached in this example. And you have to check all the balance that those transactions involve. And you have to check if indeed between all the transactions that you are traversing and verifying, there is anything that basically violates the double spending rule. And what you start to understand now that basically for the new transaction like this, you identify these 2 points. You have a set of transactions here for which you validate and check this rule. Then you have some other here and the other transaction for which you check and validate this rule. And this is done many more times, many more transactions arrive by different nodes that receive this transaction. So in a way, what you do, it's in a distributed and decentralized way between different nodes that hold the ledger and receive transactions like this that have to process, you validate the existing transaction into the network. So by doing this in a decentralized and distributed way, there is no way for the different nodes that do this process to find an agreement on saying that some transactions that are actually violating the double spending rule are not. So in this way, you have a decentralized control and check of all the transactions, and you have to do this multiple times, and you do this many more times, many more transactions you receive, for which you can say that basically these transactions that now are green and are closer to the genesis have undergone a lot of checks that are enough to say those transactions are valid because it's been checked by many other nodes in a decentralized way, and they didn't raise any flag for having basically double spending. So you can start to say, okay, these transactions are good. With high confidence, there is double spending, and this is where you trigger finality of transaction, where you can say that transactions are basically final. So there is no more way to change those transactions that didn't basically violate the double spending, and I can consider those transactions final. If you think that that transaction for you represent the exchange of some goods for an e-commerce, let's say, transaction, somebody buying something online, then that is the time for you to say, okay, the money that I received, there was not attempt to double spend some existing token, so there is no problem that this token doesn't exist. I can send the goods that somebody tried to buy. So, and what you see is basically that this green start to flood the whole network from the genesis toward the edges where new transactions are over time. So over time, you will see that the violet will become green because there will be new transactions that will trigger new search, new path and new checking of this transaction, so they become green. So this way propagate the new unreferenced transactions that are not anymore unreferenced because they connect to the network become violet. There will be new unreferenced one that attach, and so on and so forth. So in this way, you know that the wave of high confidence final transaction will propagate, and you will start to see a structure that basically have received all the different validation, and you can consider final, you can consider validated. So at the end, what you will have is basically, you will have that all the network, you can put a threshold, you can say that basically those that have received 80% of transaction checks among the overall number of transactions, they can be considered final. So you can put different threshold, and this threshold is actually something that you can even put yourself. Like I said before, in the case that you want to exchange some goods for some value, you can decide that you want to wait until this confidence is 80%, or you can wait until the confidence is 99%, because sooner or later, with new transactions arriving to the network, there will be enough number of checks that those transactions will receive, so for which your green confidence can be up to the threshold that you want. So it is clear now that for having a confirmation threshold that is arbitrarily chosen and based on exactly a threshold and based on this collaborative work, you need to have the more transaction you have, the faster this happen, because the more transaction you have, the faster one specific transaction that already exists will be taken into different path and verified by different node, and will be considered final. So IOTA is actually now a ledger that, conversely with many other that we have seen the bottleneck in the Bitcoin blockchain, where more transaction you have, the bigger is the bottleneck, because they have to fit into the scarce resource that the miner offer, and then you have to start incentivize going in front of the queue with the fees. In IOTA, it's the opposite. So the more transaction you have, they can go to different nodes and trigger different work from different nodes to validate the ledger. And actually the ledger, in terms of confidence and confirmation threshold, achieve confirmation faster than with less transactions. So the more transaction you have, the faster achieving this confirmation becomes. So IOTA is actually a ledger that, apart the physical limit of the channel, the internet channel that is requested to exchange message to define this path, or receive transaction, process transaction, but like any normal other server now when it has to process data on internet. So there is no limitation in the way you achieve consensus. So the more transaction you have, the faster the consensus is achieved. And this is one of the benefits of IOTA. So to summarize this, there is no dichotomy in IOTA between miner and user or client that want to send transactions. The user validate the network without paying fees. So if you talk now about IOTA token, you transmit one token and you receive one token. And the validation that I explained before, in the end, doesn't require anymore those crypto puzzle like a proof of work, race of proof of work between miners. So solving this very complex crypto puzzle, finding the number of required zero start hashing and hashing and hashing a transaction that is requiring Bitcoin blockchain or other proof of work based blockchain. So that require a lot of effort. All the validation, distributed validation that IOTA nodes do is basically based on a mathematical check that transaction doesn't violate the double spending, and this is repeated over time, and require only some CPU cycle and some probably a bit more memory space because you need to hold the structure of the path that you identified in memory to check the transaction that are contained into that. But it's doable with a normal computer. You don't talk anymore about server farm, but you talk about normal server that can run the IOTA ledger. So this is makes also the ledger distribution power, let's say, of the network much more democratic than, let's say, this centralized into the hands of some big hashing farms like we have in different blockchain that can also add new risk of the ledger in the end be controlled by some entity only. So IOTA becomes much more democratic. The DAG offers scalability, you don't have fee, and it brings, because it removes as a main function for the ledger, we all know that proof of work is a very expensive, not only in terms of hardware requested, but also in the cost of that hardware, but also in terms of energy, remove that bottleneck. So IOTA has a very low energy consumption because it doesn't rely heavily on proof of work like other ledgers. So, but these checks are much more doable without too much energy resource. So, and yeah, we can say we did some estimation. It's always very difficult to compare different ledgers and blockchain. You might end up comparing peer to Apple, and actually, yeah, branch of research should really focus on doing this in a scientific way more than industry can do. But in principle, if you focus only on the value of energy cost brought by the use of proof of work into the different ledger, whether it's a blockchain-based proof of work or it's a IOTA Tangle, if you only compare this function, we can see that with the cost of a cup of coffee in terms of energy consumption and the proof of work requested by IOTA, you can do 22,000 IOTA transaction, and there are other numbers that we extract. As I said, we have to be careful with this number because scientific can need to be done properly, but other estimation says that when you run a Bitcoin transaction with that cost of proof of work, you can perform with the same cost of energy associated to that proof of work, 600 million of IOTA transactions. So this gives the idea now that this ledger way of providing the consensus it's suitable for Internet of Things, because other than removing the fee, it gives the scalability of processing transaction without adding an extra cost for this infrastructure that otherwise you will have, whether it's in payment for the fees, whether it's in energy, for other technology. So it seems that IOTA achieved its goal. Whatever I said so far, it's what we call IOTA 1.0, sorry, 1.5, which is actually currently available in the IOTA network. There is the possibility to run the IOTA node, which is called Hornet. Anybody can download and can join and be part of the network. The network is permissionless. This means that everybody can run an IOTA node that connects to the existing network. There is no need to validate the node. There is not even a way to decide that who is actually part of the network, like in permissioned network, which creates some kind of false, or let's say halfway to complete decentralized trust, because still you have to trust the node that are part managing the network. Although this might be distributed by different organizations, there's still some kind of smaller group. In the IOTA, everything is permissionless, and everybody can run a node, so you don't need to trust the behavior of some nodes because they're owned by some organization, but the network as a whole, it's all flat, and everybody provide a resource to the ledger validation. And current node is called Hornet. We can run smart contract, tokenized asset, and of course, the network scale up to 1,000 transactions or even more per second, and achieve this. Like I said, permissioned environment relax some of the constraint. and achieve greater security with energy efficiency and scalability. In IOTA, we managed to do this with the use of the tangle and the DAG structure without putting those constraints on who actually can provide resource to the network. This required to be prone, but also reliable to more and different attacks that you might have in a permissionless network, but the IOTA protocol hold and provide this work. Quick overview. I don't know how I'm doing in terms of time. I hope I'm still good. Quick overview on basically how all of this works and how this is evolving now toward what is the future of IOTA, which is called IOTA 2.0, IOTA 2.0, which add a few other elements to the protocol in order to speed up and achieve even faster consensus, faster confirmation time, and even higher scalability in the network, although the core remain the DAG, remain the decentralized acyclic graph and the more distributed structure over the blockchain. But basically, when you think about a ledger infrastructure, you basically have the peering functionality, so the ability of these new nodes that are part of the network and all the ledger to connect themselves. So we are in a wireless system conference, so everybody's very familiar with the concept of peering to the network. Then you have the networking side, you have the need for the message exchange that help to acquire the information that I said before, identifying the path from the genesis to the reference transaction that we call tip, and how to connect them, exchanging message about I validate this transaction, so the ledger now for this part is consistent. All of this is the networking, and all of this, again, need to be done preventing spam, preventing attacker that just want to congest the network, they just want to create denial of service attack, they want to bring some nodes down, but still be efficient in order to not add as much overhead, too much overhead into the message exchange. So we know that otherwise the network itself that will have to live on internet will have the limitation of the bandwidth that you are available. So also the networking part need to be designed properly. So this work that our research team is doing. And on top of that, you have the consensus that I explained before. So of course, all of these need to prevent spam, need to prevent malicious actor, and need to have a civil protection mechanism. So where you avoid that basically fake accounts are created to inject particular attack to disrupt the network or try to create double spending, let's say, activities and so on and so forth. All of these need to be protected by some civil protection mechanism. And of course, the ledger itself might grow. And since it's a permissionless network, there are ways to also balance the growth of the ledger by creating data sharding, by basically create node that process only a subset of all the message, all the transaction that arrive to IOTA node. So basically, in future, what we are evolving is that not all the nodes have to maintain the same copy of the ledger, but you can start to partition this in different areas, whether it's geographic, whether it's based on who actually is behind those nodes, in order to create, let's say, also more balanced creation of the ledger that doesn't need to be replicated in all the network. And this speed up also the creation of new nodes, connection to the network, synchronization, and so on and so forth. Very simple on how to generate transactions that are value transaction in the IOTA network. Basically, you have a seed, which is your master seed for controlling all the different address from which you can spend tokens. So basically, with a seed, you create a sub-seed, and every sub-seed, of course, have associated a private key that is the one that enables you to release the spending of the token, and the others from which you can spend the token. And of course, owning a private key is basically owning the token, and it's a proof of ownership of the token that you have. That's very standard. One thing you were to point out, IOTA has this transaction structure. The important thing is that also the transaction structure has a payload where you can actually add information that are not necessarily related to the transaction. So in this way, you can actually generate a transaction that is transferring zero value. So it doesn't need to move token from A to B, but it create only a transaction that contains this payload, which is a message. In this case, any message maybe can be a sensor data value and so on and so forth, that you want to just push the network in the same way you push other transaction to be validated by all the different nodes to achieve the goal that when the the network is validating this transaction will be replicated across all the nodes. They will stay there forever. So you can't remove one copy and say that that value doesn't exist. So the value remains immutable, and you can use this to anchor immutable value into the ledger. One thing that is going to be introduced into the IOTA protocol for, like I said, removing the problem of CBIL protection, adding the CBIL protection, removing the problem of CBIL attack, is basically the idea of mitigating the behavior of bad actors that are only there to disrupt the network. And for doing this, like I said, there could be use of proof of work to prevent spam. On the client side, the client need to do some little proof of work in the past, and how IOTA still 1.5 works in order to guarantee the fact that you as a client have interest to send it transaction, because you attach to it a little very simple proof of work that can be still managed by IoT device. But this proves that you actually have interest to, if you have done this work, to send this transaction to the network. Anyway, in order to remove this, we are creating a system that is based on a node reputation and a client reputation, which is called basically a mana. So mana is a token that basically every time you perform a transaction that is actually valid, you basically stake some of this mana. And when the transaction is done successfully, you receive the mana back. So basically, what does it mean? This means that now there are nodes that basically hold more mana, and the nodes that hold more mana are those that basically have less, let's say, constraint in terms to access the network, because they prove that they are honest, they have an honest behavior. So with this, we can relax all the other mechanisms for CBIL protection. So this makes much easier to reward good behavior, and those that have good behavior that can be observed and can be acquired by showing how many mana you have staked and you have received because you have done good work in sending good transaction, allow you to reduce the other CBIL protection mechanism like the proof of work and so on and so forth. And you can imagine that basically there is a mana, a node that is behind an IoT deployment where you receive thousands and thousands of IoT sensor data, and you don't want for this IoT sensor database, maybe in your factory, to every time have to do the proof of work, because it might be still doable, but affect the behavior of your network, might slow down, things like this. But if you are connecting to a node that has a high stake of mana and can show that it's actually a trusted and well working node, then you can see this lower down for your network. So you get the advantage that your nodes, IoT nodes, doesn't need to do anymore this job as a client when sending transactions. So it creates, like I said, a rewarding of good behavior, but still maintaining the network free from CBIL attack. And that's basically one way to use the mana. Other way mana will be used in the future will be also to achieve consensus in a faster way than I explained before. Like I explained before, you have to do all these decentralized checks, and depending on the threshold that you set, how many times that transaction was reviewed, you can basically think that it's final, confirm. In future, you can do this also based on voting, and the voting that comes from node that have higher value of mana, they will be more trusted in voting. Okay, this transaction has now confirmation time is final, and is not a transaction at this time to do double spending. That's another way mana will be used in the future and just be introduced. So I explained the congestion control mechanism already that you have using mana, and the main idea is to actually remove also the network limitation otherwise that you have in exchanging all the information that from the upper layer are required in order to maintain the consensus of the ledger. And as I said, again, the voting can be used in order to node with higher mana can vote on transaction that basically can be considered confirmed faster than other, or can to break ties when there is actually not clarity about what transaction is creating double spending, because part of the network says that it is, part of the network says that it doesn't. So you can break ties using mana and the value of mana. Like I said before, just to conclude this theoretical part, the sharding basically allow us to create different subtangle, and the tangle being a graph is very well easy to, it's better to be sharded, because you can start to spin out different tangle that are part of the main tangle. And the main idea will be that what we call leaf tangle include actual data. You can actually do this better for data, because data doesn't need to be known by all the network, the data transaction. So you can start to create at the bottom of what we call our data sharding mechanism, starting from the main tangle, different branch tangle that contain in the leaf tangle only portion of some data transaction that you want to store in only one portion of the network, not all of them. Very quickly, all of this has been created and maintained and give to the community as open source software by the IOTA Foundation. IOTA Foundation is a not-for-profit organization registered in Germany, and since 2017, first foundation actually create from a token donation that we received back from those that hold the IOTA token. So we are probably now more than this, 150 people from 30 nationalities that share a vision and work in a decentralized way, like the protocol IOTA does already since before the pandemic. There is a number of tools available. Like I said, at the core there is the ledger that's open source and has the different protocol and different nodes implementation that you can run. Everybody can connect, and then we have a set of second layer protocol, which quickly I will present, and then we have all the different solutions that our community is building on. Like I said, it's already quite known in the research environment, IOTA, but we hope to see more and more research based on IOTA in the future. We are also fostering research and supporting research with some grants that IOTA Foundation distributed as well as a funding organization, and few communities. Of course, we have our mainnet where you can see all of this working in practice and live. You can actually use real IOTA token. You can actually implement use case where machine can pay for their data exchange for their services. And we have also what is called IOTA 2.0, which is the test network now in its final phase of testing the new future of the product that will be released in future in the mainnet. We have few community you can join, particular for maybe the research environment. IOTA Cafe is our public research forum. We have a channel on Discord, and we have the ecosystem where you can see all the different solutions that the community is building on IOTA. In terms of tools, IOTA provides decentralized digital identities. I don't know how familiar you are with this, but I'm sure you are. Decentralized digital identity is a way to anchor to the ledger, basically, public key that allow the owner of the public key to basically show some credentials that are received and collect locally and signed by other organizations that are called issuers that actually own the same public key, their public key. So in this way, the verification process is completely decentralized, because a verifier received from the owner, the holder of an identity, the public key, the credential, and the credential always there are standards for doing this. We follow the W3C standard and did the decentralized identity document and the verifiable credential. So the credential always hold the identifier, the public key of the holder to which has been issued, and are signed with the private key of the issuer that issued this public key. So the verifier can now simply receive the credential, can verify that belongs to the holder that is presenting it, and has been signed by a recognized issuer by simply verifying through the public key that can read from the ledger the signature that is valid. So this way, the verification process becomes decentralized. You don't need anymore to basically have a central point of identification of identity management system. So, and all of this is very scalable, lightweight, and works for people that can start to create their self-sovereign identity and attach credentials that receive a different organization. You can do for organization itself. You can even do for IoT device, which is the important things. You can even use this to prove that an IoT device has some specific feature in terms of credential as being issued by a given manufacturer and so on and so forth. Streams are another second layer protocol that allow to link transaction that belongs to the same entity in the IOTA ledger. The advantage is now that if you want to use the ledger to store data points from a given sensor, so you have already a fixed structure that allow you to know where each data point is going. In different ledger, you will have to maintain an indexing structure of chain that sometimes become much more heavy in terms of information than the ledger itself. Not manageable by IoT device. With streams, you can create this channel, virtual channel, in a way that's much more simple. So the device creating the channel only need to hold an information to know where all its data points are stored in the ledger, and eventually use this information to pass to a third party that want to read data. So this allows really to create very simple way to have self-sovereign control on the IoT, on any data you store on the ledger. We have smart contract, second layer protocol, smart contract. They don't run on all the nodes in the network. The advantage is that, different from that, they're not a limited resource like in other blockchain like Ethereum, so they don't need all the incentivization mechanism, the fee to pay for gas that is converted to Ether for running a smart contract. In IOTA, this can be removed because different smart contracts can run at different time or in the same time in the network, in different portion of the network, still maintaining the required security, but achieving more scalability and lower fees. Of course, in IOTA, you can create tokenization and tokenized asset, non-fungible, fungible, and any sort of asset that you can use to foster your ecosystem of application end user. Very quickly, few example. I think I'm running, I don't know, I'm with time because actually we started quarter past, but I don't want to create too much delay for the next sessions. I think I take 10, 15 minutes more to go to the use case, and I'll be happy to talk more offline in case of questions. But yeah, let's analyze some of the use cases. We work with different industry, work with different partners in different projects. So far, we have been focusing mainly global trade and supply chain. We have been focusing smart cities and energy, smart energy as a vertical, automotive, of course, and telecommunication, but also on adoption of different new solution like secure digital identities has been one of these. Some example of this work done so far. For instance, in my domain, the telecommunication industry, there are different problems, especially in the new, let's say, wave of 5G services. So the network is much more relying on a virtual service, virtualization of services, and a network infrastructure that is actually not anymore confined to a given network operator, but can cut across different network operators. If you think about especially IoT and all the smart techs, let's say use case going from smart factories down to smart logistics and so on and so forth. So you imagine that all these services have to traverse a number of networks because they are not static services sitting in only one geography. So they need to cut across some of them. So, and with the 5G, you can create basically virtualized architecture that sits on top of different network. You don't care about the network, you just care about the service. But in order to do this, you have to access still the low level network infrastructure from different network providers. So one way to do this is to create a marketplace for assets where basically the different assets are shared, and you need to track access from an application point of view of who's actually accessing the different infrastructure provided by one network provider, and so on and so forth, in order to distribute payments, but also track responsibility. Things don't go well. IOTA has been part of an initiative with the TM Forum in order to connect these different assets, to also measure and share data about their use using IoT infrastructure in order to distribute in future payments that can happen with token, but also happening with the normal currency, for enabling this new make and rent model rather than make and use model that has been in the industry for too long before 5G, and only create a very high capital investment that sometimes is not rewarded. So in this way, new way of using the network infrastructure can be, telecommunication infrastructure can be enabled. In the ecosystem, in the e-commerce, we are actually working on a few things. We are actually using the ledger to basically share IoT data that are used to monitor the e-commerce infrastructure, in particular the logistic infrastructure, that is a critical infrastructure in order to monitor the goods delivery and so on and so forth, the timely delivery, and eventually put fines if this is not done in time. But all of this require monitoring the infrastructure and sharing infrastructure with tools that has been developed inside the project we are working in SureSec in a secure way across different ecosystems that belongs to different organizations. So the ledger is the layer for sharing this information, as well as we are using decentralized digital identities for basically enabling and simplify the access of services. So you don't need anymore now to register your identity, be verified if you are, let's say, above 18 customer from a given website and things like this, but you can bring this information as a credential that, for instance, another service give it to you, like a bank. So all of this brings benefit in terms of there is minimization of data share, personal data share, and also minimization of data contained in different systems that sometimes are exposed to attack, like small and medium seller on internet can have the security that is required for holding this data. Very last, I guess, and I conclude, use case is about peer-to-peer energy trading, which is very IoT related. The idea behind this is that basically with new renewable energy, so you will have solar panel on the one side, you will have as well batteries on the other side that can transact on internet in order to basically buy energy from renewable source from your neighbor. So you don't need to anymore go to the smart grid, you don't need to anymore, to the grid, you don't need anymore to pay for a fixed bill, but you can source energy on demand when it's needed. And in order to do this, you need smart meter that are able to basically monitor the energy that your solar panel is producing. And on the other end, you need to monitor the energy that your house, for instance, need and your battery need to accumulate. All of these need two layers. One is to exchange information about the energy that somebody has in surplus that want to give to somebody else, and the energy that somebody might require because it's in deficit. So all of this need to an infrastructure that is not owned by anybody, but can be there and used by everybody instead, like the ledger, where the information you put remain immutable, it can be traced. So sharing information about demand and offer on the ledger is one level. And secondly, you can enable peer-to-peer payment. You can enable the payment from one device consuming energy to the device offering energy directly from the device itself. So by hosting an IOTA wallet, you can enable this when the transaction is secure. So I think these are also interesting use case, but I don't know, conscious of the time, please let me know. We can even stop here. I think I gave a good flavor of the different use cases so far.
Thanks a lot, Michel. Thanks for your very interesting talk.
So I think the conclusion was just, a few more use case, make the slides available if you want. Okay. But yeah, I would say that that's about it, IOTA. And I would say that, being here in a wireless system conference, I think the imagination is just the limit for integrating IOTA with different use case or research challenge that in this world we're trying to solve and address.
Okay. Yeah. Thanks. It's wonderful to see all these interesting use cases as well.
Thank you.
So we do have some time for questions. I may ask the audience to type in the questions in the Slack channel. We've already received a couple, so I might actually go through them. So Luke Gerritz is asking, it's actually a multi-part question. So let me read it out first. So how is it possible to have a global state in IOTA? If yes, how is it achieved? In a classical blockchain, smart contracts depend on a global state common in each node. In IOTA, there are, if we understood correctly, there are multiple tips and there's multiple states in the nodes. Also, this global state in blockchain allows smart contracts. Are there any smart contracts in IOTA? And if so, how do they work?
Okay. Yes, probably the question was written before we went to the smart contract, and probably was too fast addressing the smart contract. Let's start from the bottom of the question. The smart contract, yes, are available in IOTA, and like I said, the smart contract still use the ledger to store the state of the smart contract into the ledger. But the computation of the smart contract is not done anymore by all the nodes in the network, one at a time, for each smart contract, but by a subset which we call the committee. So this can be configured and can be decided number of nodes execute the smart contract, maybe 5, 10, whatever. And they need to sign, of course, the execution of the smart contract and there's different states and write into the ledger. And there is the correct execution of the smart contract only when a threshold that is again can be configured. It's passed. So, for instance, 7 out of 10 node agree on the same execution of the smart contract, and the state is verifiable into the ledger. So this allows to scale the smart contract execution and reduce the fee that otherwise you have to do for the same principle, like I said before, that you have a limited resource, the node that executes the smart contract, and a number of different smart contracts need to be performed. To the first question, like I said before, tips arrive, attach are known as entry point to specific node, but of course, the node takes the tips, use this to trigger the validation of existing transactions. And when this is done, the state that the node, let's say, achieve is propagated to the rest of the network. So then for new tips, at some point, all of this goes to the rest of the network using some gossip protocol. So all of the ledger is maintained consistent into every single node. So this is achieved. And of course, at some point, you achieve also the confirmation time. You also know that some portion of the ledger states it's immutable, it won't change anymore because no double spending has been detected by that number of nodes. So this is written in the stone and forever. So, and other will achieve this over time, but the state is always, of course, replicated. Even if this starts from one node where the transaction, the tip has to touch, then it is replicated everywhere. Hopefully this answers the question. Yeah.
Yeah, thanks, Michelle. So another question was on scalabilities. The question is from Majid. He's asking, can you brief on the solution how the scalability would be kept intact in IOTA ledger as form of permanode, and will small scale IoT vendors be able to support it?
Okay, I think there are few elements here. The scalability, if I understood it right, so the scalability is guaranteed by the Tangle itself, and of course, like I said, there is already around 1,000 transactions per second that can be processed in the network. The only scalability will be the constraint of the network in terms of sharing this information. So we are developing more efficient way to sharing this information, but we aim for over 10,000 transactions per second, and there are then two elements: time and space scalability. In terms of time, the confirmation time is already below 1 second. So I think any other blockchain does the best can do is something like that. So this, of course, will have a finite time, can be immediate because information need to be exchanged. So I think that is already good. Can be a bit better, but I think that's already close to the limits. But the space scalability, if understood right, some reference to the permanodes and so on and so forth. Of course, we don't want that all the nodes hold every transaction because the ledger will grow too much. And this already, there are few ways to limit this. There are what is called snapshot. So basically in IOTA ledger, if you don't need to, when transaction becomes secure, like I said, confirm the green wave. So those transactions, we don't need to have any more the detail about that transaction being generated by another transaction and so on and so forth. But what we want to maintain is basically only the balance of each wallet involved. So we don't need to anymore the history at some point. So this can be pruned, but can also be maintained in permanodes and things like this, alongside with the data points only that are not value transactions. So of course, the permanent network will grow and will scale. We'll have to scale in terms of storage resource, but of course, storage resource becomes also a bottleneck. But that's also why in parallel there will be data sharding. So where not necessarily in order to know that the consistency of the network is maintained, that all the nodes have to maintain all the different data points and different ledgers. So you can start to distribute this across nodes. So in the end, you have different ledgers that are still consistent, but the detail of one is maintaining a portion of the network and the detail of another one is maintaining another portion of the network. So this will be a way to cope with the limitation also of space scalability, let's say. The last part of the question was when IOTA could run on the on IoT device. Well, as a client, it can already run on IoT device. We don't have, of course, clarity on the definition of Raspberry Pi as an IoT device. I wouldn't say that it's an IoT device, but it's still an embedded device. And the ledger can run eventually the node that receive transaction and maintain the ledger basically can run on a Raspberry Pi. I don't think we want to go to a real IoT device that is only behavior is doing sensing, be able to be part of this process of accepting a validated transaction, but that IoT device will only be a client. As long that client is connect to a node that is only one step away, one hop away, let's say, I will consider this trusted enough with the end-to-end security. I will say that that's already the optimal scenario. So I can imagine in a factory having all the sensor highly embedded, producing data and sending data to the local gateway, and that local gateway be an IOTA node, which can be. So from there, I think the end-to-end security is not broken anyway. So we can push even further this and try to run micro node on the IoT device, but still I don't see the value with respect to the benefit, because the single IoT device will be just one entity that is able to run host its own ledger, but for its own transactions, I think it's a quite limited use case. But yeah, maybe research can be pushed in that direction as well. I'm happy already for some more powerful, like it is now, embedded, maintain the ledger, and there is only one hop between the sensing part and that gateway hosting the node. So from there, we can be 100% sure that there is end-to-end security and the ledger is fully exploited.
Thanks, Michel. Wonderful. So yeah, I think we are sort of running a little behind time. So thank you again for this very interesting and insightful talk. I'm sure the audience got a lot out of it. So yeah, please join me in thanking Michel for his time and the wonderful talk. We'll now move on to the next session, and I'll pass on to Professor Raja Jordak, who will be chairing the next session. Thank you.
All right, thanks, Salil. Hello, everyone from Brisbane in Australia. I'll be chairing this session where we have an invited talk that's very interesting from David Davies, who's also based in our area, I think in the Gold Coast, not far away from where I am. And a brief introduction to David. So he's been the founder and CEO of several successful startups in fintech, software as a service, and the mobile area. He spent some time in his career in global investment banks, including Goldman Sachs, Lehman, and others. And David's been very active internationally, so he's presented some keynote speeches at various international venues. His company, AgUnity, was also awarded the Best Innovation by a startup at the Agriculture 2018 event. And also, he's been named the Agripreneur of the Year in 2018 by the Future Agro Challenge. David has a deep understanding of cryptography, distributed crypto ledgers, and looking at trust, digital identity, and financial inclusion, particularly in developing communities. So with that, I'll pass on to David. And David, if you could please share your screen when you get a chance.
Sure, I will do that. So hi everyone, I'm David Davies, the founder of AgUnity, and we take simple smartphones like this one and we transform them into a life-changing tool for remote smallholder farmers in developing nations. Share. Cool. So all these farmers you see on the screen, we enabled them to increase their income, gave them access to marketplace, affordable credit, financing, and a whole lot more. And the problem we solve is that hardly any technical solutions are made that are useful or helpful for these remote farming communities. And since they're, by definition, they're living in abject poverty, so they have so little money that they mostly get ignored by most of the people that could deliver solutions for them. So let's just talk about the crux of this problem. Coffee, chocolate, tea, vanilla, and all the coconut products. Look, almost everyone enjoys one or more of these products every single day. And I say enjoy very specifically because these are all things that we could live our life without if we needed to. But did you know that the vast majority of these products are grown by farmers living in extreme poverty, and they are paid so little for them that they and their family and community are trapped in a life that is pretty much the modern version of slavery? And the low farm prices that farmers get paid, they're behind all sorts of other problems, right? From child labor to food insecurity, exploitation of women. So many of those things really come back to poverty, which is driven by the fact that all of us in the developed world, we're enjoying these products, but a very small trickle of what we pay for products actually gets to the farmers at the end of the cycle that are doing all the work. So what could we do? Should we stop buying these products? Hell no. The small income that these farmers earn is still way better than nothing going into their economies, right? And also, let's face it, a big part of the world literally could not function without coffee on a daily basis. And it seems like the magnitude of this problem has been known for a few thousand years. There is no simple solution, or it would have been solved already. The NGOs, and many of whom we work with and know very well, they're investing hundreds of billions of dollars a year on this problem. But that also doesn't mean it's impossible. There are just a few key things that we need to put in place to make a real impact on this. And that starts with the fact that those 500 million smallholder farmers, that's the real number, and it's not just them. Those 500 million farmers, they support an ecosystem of about 3.1 billion people. Their families, the people that live in their villages that provide other services to them, the people in the food supply chains, and the people that depend on the low-cost foods that they produce. That's about 40% of the world. People that depend on these very smallholder farmers, but because they're often in remote locations, they're very easy to ignore. It's difficult to understand exactly what their problems are. So mostly companies just don't make that effort, and they don't produce solutions that would actually help these farmers. They tend to focus on a different demographic, which is understandable. It's a very hard market to work in. So AgUnity transforms phones to address the very unique requirements of smallholder farmers. So while the phone is perfectly normal out of the box, we take it, we replace the Android operating system with a tweaked version of our own, and we solve things like the lack of connectivity, the fact that they've got no banks, that most of our farmers have very low literacy. They understand numbers, but they couldn't read. And our phones connect that to a cloud and blockchain-based record-keeping system. And we use blockchain in the most simple way. It's an immutable transaction log that runs in parallel to our cloud, and it really just improves the trust and security. It's there so that when farmers do a transaction between each other, and when it does get written to the blockchain or cloud, they know that that transaction's been written and it can never be changed. Because the trust in those communities is really one of the major things that's holding them back. And that's something that good, simple record keeping on a phone can do. So what AgUnity does is actually incredibly simple. It's so simple that when we explain it, people often go, it can't be that easy. What we do is we enable the farmers to do all the transactions that they really need to do. A farmer in a remote village of Bougainville in Papua New Guinea, they don't need to book an Uber. They don't need to do any of the things that we do on our mobile phones. They have other very specific needs, such as how do I hand over my crop? How do I buy a solar light? How do I get some fertilizer? How do I know what fertilizer I should be using? So to those farmers, we provide an all-encompassed phone that is, to them, it's sort of like Xero as an accounting package. It's a bit of eBay so that they can order things. It's a bit of PayPal so they can do transactions amongst themselves and transact things without having everything relying on cash. And it's a bit of Alibaba so that they can actually get their products into a supply chain and get a fair price for them. And we've been doing this now for over 5 years, 5.5 years now, and that's all over the world. Our projects span from Colombia to Ethiopia to Papua New Guinea. And our founding team, we actually come from a very different background. Our technical team were all senior vice presidents at Lehman, Goldman, and Nomura in Tokyo and Singapore, where we ran mission critical teams. And I personally founded 2 companies in Japan and Singapore that were both acquired. But then we've got another angle to our business, which is very important in this. Angus and Nervit, who are part of our team, they bring environmental, humanitarian, and we hire a lot of people from NGOs and farming organizations and support for the farmers. Because to solve this problem, you not only need to be able to build the technology in a scalable, global, and often very complicated way, but you need to do that in a way that's relevant to a demographic that most people have never met. And that's why we bring in those people. And then very importantly, we brought in Paget Hargraves, who runs the Agriet Foundation. And we'll get to Agriet in a minute and what that does. But Paget's background is very important. He was previously the founder of a $200 million desert greenhouse facility in Port Augusta in South Australia called Subdrop Farms. This is the biggest greenhouse facility in the world. It uses entirely solar power, it desalinates water, and grows trellis tomatoes for the 2nd biggest supermarket chain in Australia. And it's a great model for how you can turn a desert environment into a productive farm facility. And then after that, Paget went on and founded a $400 million medicinal cannabis facility, which is by far the biggest facility in Australia. And then apart from the management team, we have a really incredible and diverse team of over 50 people in 19 countries now. And I'm pointing this out because one of the most important things, the reason why we can do what we can do, and we learned a lot of this because of COVID actually, it kind of helped us change our model, that was to hire local people, which is actually a lower cost than flying people around the world, and get that local knowledge. So this is why we've got people spread across 19 countries. And so we have teams in the country, boots on the ground, but these people actually spend time in the farming communities. They live and they eat, and very importantly, they often go out and get drinking with the farmers, because that's how you get the real information and how the farmers will tell you what they really need and what could really make a difference in their lives. So unlike other companies, we have a very unique way of getting to these farmer users who cannot be reached by any normal means. So you can't just buy Facebook marketing and get to our users, because 90% of them never owned a phone or computer before in their lives. We're literally giving them their first phone. If they have had a phone, it's probably some old feature phone that they can just use for calls and SMSs. So our projects usually start with a partnership or grant, and we roll out about 100 farmers in a trial. We've done these all over the world now. And after a season, we go back to the farmers and we say, how was it? Did it work? Did it help you? And we normally get about 100% of them decide to keep, and then they pay off the phone. And as they pay off the phone, that money becomes available, and we can get more, we can make the system available and get phones for more farmers and onboard them. So we have thousands more farmers in Ethiopia, for example, just waiting to get phones, and our Unity is a bit constrained by our own capital and how long it takes the farmers to pay off the phone. But the growing community, what's so important about that is once you make the farming community more efficient, they produce more commodities, they buy more products and services. So this makes them attractive for our partner companies, because they can reach more people that they never would have been able to reach before. Say the companies selling solar lights or fertilizers, or the NGOs trying to work with farmers, and most importantly, the commodity buyers who previously were buying coffee from a port. Now they've got a whole community of farmers, and if they tell them they need more coffee, then that community will grow to suit their needs. So we're actually connecting the whole supply chains back and forth into a community that previously nobody even really knew existed. And Ag Unity has, we've now got over $1 million. It's taken us a long time to get here. We have over $1 million of revenue from, and it's a mix of partners that we work with, from big commodity buyers, financial institutions, and NGOs, like organizations like Fairtrade International, USAID, UNCDF, and World Food Programme, all of which we love working with. And what we really do for them is we enable them to scale up and actually reach these farmers. Our system has survey applications, we have data collection facilities, so we can tell organizations like World Food Programme how much their other projects is really impacting the farmers. But the main thing we really achieve is by getting groups of farmers together, getting them organized so the system records everything, we improve the supply chains. We reduce tons of waste, particularly in the chocolate cocoa industry. So much cocoa just goes to waste because the supply chains are inefficient and it rots pretty quickly before it's dried. So we reduce a lot of waste, we improve the efficiency, and that leads to a lot of benefits to farmers. We've had many cases where we've, in a single season, seen the farmers income increase by up to 3 times, which you can imagine, any one of you, what would happen if your income increased 3 times. It's life-changing, but it's not only life-changing for those farmers, it helps their families, it helps them get the kids better educated, it helps, and then they spend it in their local community. So that money's just not going to the farmers, it's going around the community multiple times. So it's a big multiplier effect when you do increase these local farmers' incomes. And while there are hundreds of solutions in the ag tech supply chain space, they're pretty much all for the larger, wealthier, and more educated farmers. They don't really go into our space. Some of them are in the middle. Some of them work for, your 10-acre farmers and things, and the farmers that have got a bit of education have got technology. But most of them don't really touch the bottom of the pyramid, which is actually where the majority of farmers are. And that group is the ones that produce all this coffee, tea, vanilla, coconut products that, everyone listening to this, I'm sure, uses all the time. So for most of those companies, this market is challenging because the farmers are hard to reach. They don't understand what they do. And more importantly, it's really hard to make money from it. So that's the main deterrent why people aren't addressing this problem. So Ag Unity, while this is difficult, it also created the great opportunity. This is the largest untapped market on earth. There is nothing bigger than 500 million farmers producing trillions of dollars of produce. And so we've adapted to a market that other organizations weren't really structured to operate in. The business models of those companies just aren't suited to selling a solution into someone who hasn't got money. You can't create a downloadable app, as most of the farmers haven't got a phone. And even if they did, and we tried that when we first started out as well, you spend more effort trying to get the farmers to install the app and support it and update it than you do just to give them a bloody phone. So that's actually how we got onto the point of giving them phones. And then we found that all the farmers, once they understand the value of a phone, they'll gladly pay for it. You can't market to them in the standard ways that were useful. You can't just charge them of a solution before they know how it works, because a smartphone to one of these farmers is months worth of income. Now, fortunately, it really gives them incredibly good returns. So once they've actually seen how it helps them and all their coffee beans a thing and they're getting high grades and better prices for things and blah, the sums, we normally have about 100% of the farmers wanting to keep the phones. In fact, you'd almost have to pry it out of their hands to get it off them. They build shelves in their houses and stuff to keep it, especially. It's their prized possession. But you have to show them it works, and then you have to feed off that. So it's a very, very different sort of business and operation than normal. And then finally, if you do get the farmers to install a downloadable app and get them working on that, how do you actually make revenue from it? And particularly in places like, say, Ethiopia, that have restraints on currency in and out of the country, it's just not suitable for most of your software companies to be able to deploy a solution there. So we've needed a unique business model, and we didn't get this right for 5 years. It's taken us a long time to refine and nail it down, because it was no easy effort. So our farmers happily pay back the phones and the onboarding cost to us over about 2 or 3 years. After they've tried it, they've benefited, know it works, and we give them a payment plan on the phone and onboarding. But we also consolidate the payments via the buyer or cooperative. So we're not trying to collect off individual farmers all over the place, which would be impossible. They're bringing their coffee or cocoa or whatever it is into a cooperative or a buyer. That organization collects the payments and then passes them on to us in one big boat. So that works very differently. So and then we get a small subscription per month that keeps the servers up and running, so we don't have to worry if nothing else happens, that whole system still runs. But the key is actually the transactions. Once the farmers earn more, they have another big problem. If you live in a remote region, how do you buy a good solar kit? How do you buy school books for your kids? How do you pay your school fees? How do you get a efficient cook stove or a water fuel? How do you even know these things exist in a lot of cases? So AgUnity's real business is very much like eBay. We get commissions on when the farmers buy products, usually via the same cooperative. So the farmer brings his cocoa beans into the cooperative, he does a transaction, he's recorded it, the cooperative will ferment it, dry it, get him a much better price for it than he would have normally got. And then he's got some money, or he or she's got some money in the cooperative, and they say, well, instead of taking this money home, where everyone's going to want a bit of it, I'm going to order a solar kit, or I'm going to earn my fertilizer, I'm going to pay my school fees. So it becomes a whole onboarding system. And that's where AgUnity really makes most of our business from. But in order to become the eBay for farmers, we had to create the whole ecosystem first. Sort of had to create the chicken before we could have the egg. So we help the farmers reduce waste, and we make them more efficient and connection, and they get a ton of benefits for that. And we've, like I said, we've seen farmers increase their income 3 times. We don't always get that, but we've had some really great results. And we have farmers all over the world who literally love this system. Prior to COVID, one of my favorite things about AgUnity was actually going out and meeting the farmers, and they'd just say the most wonderful things, like we were the best organization that ever come into their village. But the biggest problem until now, and that goes back to what I was saying at the beginning, is the farmers just get paid a ridiculously small price. So if you take coffee as an example, the farmer does most of the work, but you can see by this cup here, they get the smallest amount of value from that of anyone. A cup of coffee that costs you $2.80, the farmer gets about 7 cents, or about 2.5% of the value of that coffee. It didn't used to be like that. If we went back 30 years, the farmer was actually getting 10 to 15%. What's happened is we in the developed world have become, we've become wealthier. We pay more for coffee. We like petite coffees. I mean, I'm not sure if anyone in developed markets drinks instant coffee anymore, but our taste and our ability to pay for these things has gone up. And all the middlemen have never increased the value for the farmer. The farmer's still pretty much getting paid for coffee and chocolate and vanilla, more or less what they were being paid 30 years ago, because the supply chain manages to keep those farmers oppressed. But on the other side, there's another big problem. So we deal with a lot of big commodity buyers, and we deal with, I think, the most ethical one in the world, which is the Fair Trade Organization, but we also deal with ones that can't be so ethical because they've got competitive pressure. They need to compete with other companies, and if they pay more for coffee, it's not going to get to the farmers anyway. Most of it's going to be taken by the middlemen. For a big commodity buyer of coffee to make sure money gets to the farmer, they're going to have to pay a lot more for that coffee, and they're going to have to put systems in place like what Fair Trade has done, and we know Fair Trade very well. We do a lot of systems for them. But that increases the price of coffee. So you have a small percentage of the market, 1 or 2% of people that will go out of their way to buy Fair Trade coffee because they know they're doing something good. But most people will just buy cheap coffee. And those big companies get hammered for being involved in child slavery, indentured servitude, all sorts of abuses. But there's not a whole lot they can do about it. If they pay more, the middlemen will take it up. Very little of it will get to the farmers. And those companies are actually the biggest beneficiaries from what AgUnity does, but more importantly, and this is the most exciting topic, Agriet. So AgUnity it's been around for 5 years, and in July this year, obviously we know a lot of, AgUnity runs on blockchain. We know a lot about cryptocurrencies. We built a DLT style system prior to AgUnity from the ground up ourselves. We have very deep experience in this. But we waited a very long time before releasing a token to make sure we understood exactly the needs of the market, and we had the ecosystem to release it into that works really well. So Agriet is a direct reward system that just has no middleman. You buy $1 of Agriet, then you send it to the farmer. This is the actual real mobile site. The farmer gets $1 worth of Agriet. And because we've got the AgUnity phones and we've got the ecosystem where the cooperatives and the buyers are already buying the cocoa beans off the farmers and selling them solar kits, we can introduce a digital token into that ecosystem, and the farmers just took to it like they'd had it all along. The New Guinea farmers immediately wanted to understand if we can just get paid in Agriet. I mean, we're holding back on that. At the moment, it's just a reward system. But eventually it will get to become how they can be paid, how they can commerce, how they can buy things. The farmers use it. Usually, firstly, they want to pay off their phones quickly so other farmers can get the phones. They buy farm supplies, they pay their school fees, the equipment they need to farm better. And most importantly, that's the things they need to improve their efficiency. Because normally they're so tight, if you're caring whether your kids are going to eat tonight, you're not necessarily buying seedlings or fertilizer for the farm. And by having a little bit of extra tokens coming from people who are saying, I feel that the farmer that grew my coffee or grew the cocoa beans, cacao for my chocolate should get a decent share of it. People doing that are actually putting a lot of extra money into those communities, and those farmers are using it in productive ways. Mostly, and this is particularly true for the women farmers, they're mostly reinvesting it in their farms and families in really meaningful ways. Also, this is so important that companies can directly pay the farmer with no loss. So if a company, a big commodity buyer, a big coffee company wants to put an extra 10 cents worth of Agriet that a consumer can release to the farmer, they can do that. And all the middlemen on the way aren't going to take their clip out of it so that the farmer gets nothing. 100% of that goes directly to the farmer. But most exciting, and this is what we saw when we released this, is consumers love this because people are a little bit disillusioned with charities and NGO organizations. They're not sure, if I give $1 to them, how much is really going to go to the farmer. We work with a lot of them. We work with, I believe, some of the best ones in the world because that's who we tend to gravitate with. Usually, if 25% lands in the farmer, that's pretty much the gold standard. Very rarely does any more. We're doing that at 100%. and we're doing it in a way that the farmer uses it, and we can also see what they use it on and control it if necessary. We haven't needed to do that yet, but we can actually send the farmer a reward and say, you can only use this to pay for school fees or food or something. So we can control the ecosystem because it's a controlled currency. And this is the browser version of the same site. It's www.agrewards.com. That'll be able to connect you to the aggregate site, aggregator, where is the entity we set up for actually selling the tokens. And if you'd like to buy some aggregate and reward a farmer today, we'd love you to do that. And I'm sure you'll feel really good about that. But soon we're moving this to more commercial models. We can just buy $1 worth of aggregate on your credit card. So at the moment it's in slightly bigger bundles. Please, follow this, keep up track. Or if you want to just give the system a try, send us an email. We'll send you a little bit of aggregate to pick a farmer and reward them. But this is only really possible, releasing a digital token into a developing community, as far as I can tell, this has been the holy grail for digital currencies. Everyone says they can do it. Everyone looks at it and goes, this would be so empowering if these developing world farmers just used a digital token. But really, it's only possible because AgUnity is already used for thousands of transactions between the farmers, buyers, and cooperatives already. I don't think it's happened once or twice. Like Bangladesh is a great example, but they had a really similar, unique ecosystems similar to us. Other than that, cryptocurrencies have really never had traction in those markets. Because to be honest, what does a farmer do with a bit of Bitcoin? It's really hard for them to use. So it was easy to insert aggregate rewards into that same ecosystem because we already had the infrastructure to do it. We have hundreds of farmers, and you can see them already on the AgRewards site. You can see, what they're doing, a little bit of their history. We're getting testimonial videos loaded up now. We've got a lot of testimonial videos on our YouTube site already, but you'll see that the farmers have received the aggregate, what they're using for it, how exciting they are about it, and we're so proud of the fact that we're really having a great impact, and they love the system. So we're loading up hundreds more in Papua New Guinea any day now. We're going to Timor-Leste shortly after that. I'm very excited about what we're doing in Timor-Leste. It's a coffee project, but the organization we're working with, they have also paying the farms for growing trees for carbon credit, farmers for growing trees for carbon credits, which is a fantastic idea. The problem is it takes farmers many years to actually get a carbon credit. So they're essentially subsidizing the farmers. This is another great use of aggregate. So we're hoping that our Ethiopian farmers will get into regenerative farming and planting trees for carbon credits, and they can be paid some aggregate rewards for essentially creating carbon credits, which is a fantastic way to address the climate change. Until now, these farmers, like all the ones you see here, they were living in 100% cash-based economy. They'd take green cocoa, these coffee beans, they'd take their coffee beans into the washing station, they'd get paid cash on the spot, because if they didn't, they weren't really sure they were ever going to get paid. There was no way that a company person from our end of the world would even know any of these people existed, and yet they're producing the stuff that we use all the time. We allow you to connect with them directly, but we also give visibility on what's happening. So hopefully what we'll see over the few years is you can reward a farmer that's growing coffee that you like from the community you like. And over time, you'll see how that they're sending their kids to school, and we're running profiles on all these farmers that are developing in real time, and you'll see video testimonials. So this is a type of charity. I don't really think it's a charity. I think it's just doing your fair share. Many, many religions, all of the major monotheistic religions, have a concept of tithing, which is like the 10% of your earnings should go somewhere. I think that's probably, we've moved away from that in modern society. But what about if we just said, if I enjoy a coffee and I pay $4 for that coffee, it's reasonable that 10% should go to the farmer. So it'd be great if the farmer got 40 cents out of that coffee, and we create the mechanism where you can do that. So instead of enjoying that coffee, knowing that there's a person in slavery at the other end of it, you can say, I'll enjoy that coffee, but I'll also just make sure that the person did most of the work, got 10%, not too much. Doesn't really change the difference to us, but my word, it makes us such a difference to farming. And we're going back to a concept of how, a basic structure that many of the major world religions were based on. And no loss. We're not taking money on this. We just want to see that money gets to the farmers. And get them to pay off their phones quicker, and all we do is give more farmers phones. And like I say, we've got thousands waiting in Ethiopia to get a phone and get onto this system. So how this kind of works, farmers receive the smartphone, they pay it off with the tokens, they buy other things, they pay their monthly subscription fees, the cooperative rolls this back up. The tokens are then sold back. The commodity buyer, the buyer or the cooperative then transfers the tokens to pay off the phones and the subscription fees on the service to AgUnity. We put them back into our aggregator entity and they resell them on to coffee companies or consumers. So we have a nice closed circuit for this thing. And we are talking to some really, really major commodity buyers about this. We already work, as you saw our clients, we work with many organizations that literally transfer billions around the world. There's a very limited supply on these tokens. It's a utility token, so we don't talk about value in things, but anybody who understands how these things work should be able to do the math. Massive ecosystem, limited supply of tokens. If we get those all fully into circulation, there's a very, very good future for how this thing can develop. So yeah, we have this system live and working. Like I say, we only released the token when we already had the whole infrastructure. We had the farmers in place. We had them ready to receive it. We have the AgUnity phones in their possession. They can receive aggregate like they receive local currency or US dollars or cocoa beans or anything else. We're loading this into a market which is 500 million smallholder farmers. They produce $2.1 trillion of the commodities like coffee, cocoa, and vanilla tea, things that we use every day. They also buy $1 trillion worth of products from the developed market, and if they had access, they'd buy a whole lot more. These people, they're a massive market for natural services because they're entirely cash at the moment, and they really would, one of the first things we see when we give farmers this system is they start to treat the cooperative in the AgUnity system like it's a bank. They save their money there, they save up for things. And it's so easy then to move them to actually putting money in a bank or getting a microloan when they need a thing. One of the really interesting problems that we are trying to address is that when very small farmers have a disaster, like, the cow dies or a typhoon comes and wipes their crop, if they need to borrow money, it's from the most horrendous people at the most exorbitant rates, and it often lands them up in dire circumstances. So many farmers get into a small amount of debt, end up in suicide, or the worst outcome of that is usually those people are connected with human trafficking, so the daughter ends up in slavery to pay off the debt. And that's an intended outcome of lending money. So we can provide farmers with these things. We can also make them bankable. We make them have access to affordable credit, because previously they had no record, no identity, no proof that they had any income, no proof that they own land. We don't solve those things in a major way, but we do them enough that farmer is now loan worthy from a normal bank at normal interest rates, and they're not going to take their daughter if they don't pay. So AgUnity's business is really about plugging these billions of dollars that are lost when the commodities come our way and the products go our back, and all this cash economy. We're basically just plugging that loss. We're not really taking it from anyone. We're reducing the loss, and that's AgUnity's business model. And that enables us to, be a viable company. I think that's so important. I think we deal with a lot of NGOs and charitable organizations. They don't operate as efficiently or as targeted to purpose as a for-profit company. So I firmly believe that the best companies for solving these ones are ones that intend to be profitable, because by being profitable, you gain investment and you can scale. We also deliver huge benefit savings and open new market opportunities to the partner companies. Everyone from the ones selling farm supplies to seeds to solar kits to just general things that the farmers wants for entertainment and stuff. Also accessing into financial services, things like insurance. All our farmers never would have used any of those things. If they could get a solar light, it often remains a day's journey into the local capital. We enable the consumers, and I think this is so important, to buy ethically with trust, because so many consumers will pick up a bag of the coffee, and one of the huge respect for fair trade, and one of fair trade's biggest problems at the moment is they lose customers to brands who just say, oh, bugger it, we're not going to pay the fair trade premium anymore. We'll just stick a logo on our bag of coffee that says sustainably sourced. They don't actually sustainably source it. They just stick the logo on that says it. And there's no way to check that, as long as they're not using like a brand new logo. And people buy that coffee going, oh, this is cheaper than the fair trade one or the rainforest one. We'll just buy this. But there's a lot of companies actually saying this is sustainably sourced, ethical, blah, blah, blah. It's not. They're just doing that. We actually give the consumers a QR code on things that tells you which group of farmers grow it, and you get to reward a direct farm. You get to see what goes on in that. So I think enabling consumers to be able to have trust in the system of where they're buying, not trust the company to pay a fair price. As we said before, they can't do it, not at big scale. Small companies like Fairtrade can, but they spend a lot of effort doing that, and they've got massive systems. The bigger companies, it's just impossible for them. But it's very easy for them to give you the QR code, say, here's your farmer. If you want them to get a fair price, pay it yourself. And that, it's offloading the responsibility from them, but it's also solving the problem, or putting it in the hands of someone who might want to solve the problem. And then the most important thing we do, and this really comes to the end, is if we get our job right, we're already doing this for thousands of people, but in the next couple of years, we will enable millions of people to escape poverty. So thank you very much, and I look very forward to your questions. Please do look at our sites, and I'd be so happy if people here could participate in this program and reward a farmer for some of the things that you enjoy in your daily life.
Thank you very much, David, for a great talk. And it's really good to see how technology can be used to make a positive impact on communities that need it most. So I really enjoyed the talk. Thanks for that.
Thank you.
We do have several questions already on the chat. So we have the first one from Gauri, which asks about the technology that the farmers use, whether they use SMS, 2G or 3G, and whether you can comment on the operational cost of the mobile application.
Yeah, so that's just a really good, important question. Thank you for that. We went through a few phases of this. So the farmers do use, firstly, our phones are very different from a normal phone. They essentially have a message queue. We come from banking, so we modeled it after tip code rendezvous, if anyone's familiar. When farmers do a transaction amongst themselves, they do it with QR code between phones, and it creates an encrypted transaction on both the phones. It puts that in a queue on the phone, and then it basically waits until that farmer gets a signal by any means. And those are like really tight, small packets. So we can send those out if we get like 1 bar of signal in the middle of the night, which is pretty common in remote villages. Most parts of the world now, even and we work in some of the remote places, farmers usually know like which hill to walk up or where to go to get a little bit of signal. So we use that. We can do that if they've got connectivity, and we can do that without using up very much of their data plan, because in some countries, New Guinea in particular, the data plans are really expensive, but they are usually capped at a certain amount. So as long as you help the farmers understand what they're doing, they can go up by like, couple of meg of data, and it'll last them for months. Of our system's designed for that. The other thing, and this is really popular in Ethiopia, is we usually have the cooperative members will actually have a data plan in their phone, and they'll go out and they'll just give a hotspot to the farmer while they're out there. So the farmer will do all their transactions themselves, and then they'll hotspot off the cooperative member, and they'll get the updates to their phone. Now, the other important thing is our system's designed so the farmer doesn't have to go online. As long as we see one side of the transaction, it gets written back, it won't matter. We've got farmers in New Guinea that have actually never come online. We know they're doing transactions because we'd see the other side, but that phone has never been online and the whole system works. I should probably add, that's only possible because we kind of take over the phone. So we can build the message queue, and we can also control the comms. You wouldn't want to do that with most of the phones that are sold in developing markets, because they're typically from the cheaper phones that farmers can get are from manufacturers that load all manner of junk onto the phone. Our phones, I should explain that although it boots up like that, it is still a perfectly normal Android phone, and so they can load all their other applications onto it. But what we do is we strip off and minimize the phone, and because we control the comms channel, we can block out certain applications like Facebook, who just use a horrendous amount of data for no apparent reason, and chew up the farmer's data plan. So we can prioritize those things so it doesn't interfere with our things. So it's another one of the reasons why it's very difficult in these markets to get farmers to get their own phones and install the app on it. We have a downloadable app coming, but it's really for the partners, not for the farmers. If you want to make it work in the remote communities, you have to give them the whole package, because they have very unique needs that are not like us.
All right, thanks for that. We also have another question that's coming from Luc Geretz. I hope I pronounced that correctly. He says he likes the projects and it's a good use of the tech. He's curious about the backend technical implementation. For instance, questions like what blockchain is used, do you use smart contracts, and what consensus do you use? And also, he's asking about the links between the product and the digital ecosystem, and whether there is product tracing, for example.
Yeah, so that's quite a few questions all packed into one. So we use two blockchains, one for the token. The token's built on Celo. The main blockchain for AgUnity is built on multi-chain. We are actually in the process of we're assessing 3 blockchains, including Solana, Celo, to migrate our blockchain across to the interesting thing is the blockchain part of the blockchain part of the AgUnity system, not the digital currency, really acts like a transaction log. Everything goes into the cloud encrypted, but it also gets written to the log. And the log is so important because, as I kind of covered in my talk, the farmers lack trust. And the only reason you really need the blockchain is we can say to them, look, no, once you hand over your cocoa beans to this guy, nobody, not even AgUnity, can change that transaction. It's written on the blockchain, it's recorded forever. And amazingly, these are people in remote communities. We had one of my favorite stories is we had a guy in Bougainville in Papua New Guinea that came up on the second visit, and he said, I knows how you're doing it. Im's the blockchain that does it. Like, he was so proud that he'd had discussions with people and he'd figured out what blockchain was. We didn't talk about blockchain to him. We just said this system can never be changed, and he'd figured it out and he was so proud of it. And we've since discovered that blockchain is a technology, they don't always understand it, but a lot of people have heard about it and they've got a vague understanding of what it's doing. So blockchain creates that mechanism of trust where people who are used to being ripped off by their own governments and the police, and everybody screws these farmers. They're in the situation of having no trust in anyone, not even necessarily NGOs. And we've given them a situation where, okay, this is just like it's written in stone, and that's the way we describe it to them. So that's the back-end technology. We built the aggregate token onto Celo because it's got a lot of compatibility. We need really no transaction costs because we move small amounts. We wouldn't need it to be ecological. So Solana, Celo are sort of the 2 leaders that we're looking at for the migration as well.
And is the blockchain that you use permissioned or public that the farmers can see? I guess that with the technology, they might not be interested in that, but
no, they're not. There's actually a transparent, AgUnity is a cloud-hosted service as well. And most of the transactions, they would look at them in that. The Celo the transactions of the aggregate token, you can see them all on the Celo Explorer. We're building an interface for the farmers for that now. It should be out in about January, February. And that's just a very friendly interface. It's kind of more for consumers than the farmers. It's more that if I buy coffee and I send a farmer a tip, we don't try to be obtuse at all. We want you to know that it went to that farmer and that farmer transferred to another farmer and they bought a solar kit with it. And then that money went back to AgUnity and it went on the coffee consumer. We want people to be able to see the flow of currencies because we want it to be completely open and transparent. So we're building a very, very friendly version based on the Explorer of that.
All right, thanks. All right, we have another question from Gauri as well. which is it not essential to ensure that the token receivers carry out the correct actions before receiving the reward? And a follow-up to that is, how do you ensure that the tokens are rewarded and exchanged reliably between farmers and other stakeholders? That, just to complete that, the middleman may deceive farmers or try to deceive farmers.
Look, so firstly, I'll just carry it that there's no perfect system, and one of the differences between us and some of the organizations we work with is we don't try to be perfect, because perfect is the biggest enemy of good enough. And one of the biggest problems that these farmers have is people try to make sure everything's fair to them. We had a big debate, I won't mention the name, with one of our partner companies that was really worried that some farmers would get more than others because they looked more sympathetic. I'd rather both the farmers get something than nothing, because we tried to be overly fair to the farmers. So we don't try to lock out every system. If the farmer gets agried and somehow someone swindles them, we'll deal with that later. But mostly the system works incredibly well. We know the flow of systems. We know the farmers. They'll report to us if something goes wrong. And one of the interesting things is these people live in small, tight-knit communities. When things are transparent and they can see what's happened, they're incredibly good at sorting it out for themselves. They don't go to the police. They just sort of get together and have a discussion, and they say, no, you did this, you did that, and problem solved. The problem comes when it's a he said, she said. And actually the origin of Ag Unity was at a hackathon. We did this purely by accident. We were trying to win a prize at a hackathon in London in 2016. We tried to come up with the biggest world-changing idea we could, because it was a prize by Singularity University. And then right after we won the prize, we had Costa Peric from Gates Foundation come up to us and say, look, we see this problem all over the world and we think you just nailed it, want you to take it seriously. And so that was the inspiration that that took us forward with. But the basis of that and what we were trying to do is just to get the very, very basic solution to the farmers in a way that solves their very big problems, not to try to be the perfect solution. I think that's very important, and I think that's honestly a big impediment to some of the many organizations that work in this. And I'm not going to name them because I know they try to do their best, but there's a lot of organizations that I think if they just were a little bit more flexible about what they do, they would actually have a lot bigger impact.
All right. I think that's all the questions we had. So I'd like to thank David again for the great talk and for answering the questions in such detail. So thanks, David, for your time, and hope to talk to you again soon about the exciting work you're doing.
Cool. Since we're nearly neighbors, we should catch up sometime.
Yeah, definitely. We'll invite you to QT sometime soon.
Awesome. I come up there from time to time. All right. See you then. Thank you, everyone, for listening, and cheers.
All right. So that concludes the invited talk and this technical session. And I'll hand over now to Dr. Shantanu Pal from Queensland University of Technology, who's going to be chairing the next session.
Thank you very much, Raja. And once again, welcome all to BlockSys 2021. And my name is Shantanu Paul, and I am from QUT in Brisbane, Australia. And in next 1 hour, we will have our first technical session, and we are having 2 papers. Our first paper, titled Detecting Compromised Edge Smart Cameras Using Lightweight Environmental Fingerprint Consensus. And the paper will be presenting by Dheeraj Nagatu. Dheeraj is a PhD student of Electrical and Computer Engineering at Binghamton University, Surrey. He received his MS degree in Electrical and Computer Engineering from Binghamton University in 2016. His current research interests are multimedia forensics on the Internet of Video Things and computer network security. And I think that Dheeraj's presentation is already sent us by email in a video file. So I think Gauri will be streaming the video file right now. So hand over to Gauri.
Hello, my name is Dheeraj Nagatu, and today I'll be presenting our work on detecting compromised edge smart cameras using lightweight environmental fingerprint consensus. For the overview of our work, I'll be presenting a visual layer attack detection system, which is deployed in an IOVT environment in a distributed manner. In order to test the distributed system, we also have tested it with varying Byzantine node rates to test the system resiliencies. In order to authenticate the IOVT system, we used electrical network frequency signals as a lightweight environmental fingerprint in our consensus mechanism for authenticating multimedia recordings. The whole reason of using electrical network frequency is because of the distributed nature it has, and also the spatio-temporal fingerprinting technique it allows for digital media authentication. We have tested this on the attack vectors like false frame forgery attacks, like replay attacks, and along with the deepfake attacks, both in audio and video recordings. So all the nodes which exhibit these kind of attack vectors are marked as Byzantine nodes, and we have tested these attack vectors in our LEFC system. So for the deepfake threats on the IOVT, there are many attacks which are leveraging the low computing power devices and launching complex attacks like deepfake video streams just on any form of audio or video multimedias. In case of audio deepfake attacks, there are simple softwares which can simply train on previous source recordings and is able to replicate the source actor and can be projected into a target voice. And this can be done with training sample as little as 10 minutes. And the software is able to completely regenerate the voice of the source. And in case of video recordings, you can see here the source actor and the target actor. Here the source actor's facial expressions are projected on the target actor, and this is basically a real-time facial reenactments. There are many low computing softwares which can easily project this kind of behavior. And as for the false frame forgery attacks, the frames are just manipulated in such a way that the live perception of the real-time events are manipulated for a human monitor. So considering all these attack vectors on an IOVT environment, we need a fingerprinting technique which is also close to real time and is very robust against these kind of attacks in both the channels and audio and video channels. So we leverage electrical network frequency as our environmental fingerprint. So it's basically electrical network frequency is nothing but a power grid frequency. It varies depending on the region. For here in United States, the typical nominal frequency of ENF is 60 Hertz. And for most of the parts of the world is 50 Hertz. So for this kind of nominal frequency, the fluctuations in ENF are caused due to the load balancing mechanisms at the power generator because of the power supply and demand. And the fluctuation ranges from 59.98 to 60.02. That's basically plus or minus 0.02. Since the fluctuations are really low, here is one sample like you can see of a short recording of ENF fluctuations. Now, the reason that makes ENF very unique is its similarity throughout the power grid interconnect. It carries similar fluctuations at the same time instant. So it's hard to replicate or predict this kind of ENF signals, and also makes the wide random nature of ENF signals and the distributed nature a very reliable source for integrating into a distributed system like this. So you can see this experiment includes 2 parallel recordings being made at 2 adjacent buildings, and the fluctuations are really close. And this has been tested across multiple buildings, multiple rooms, and the results are the same. So for our system, which is an IOVT smart camera network, we want to build the deployed system typically lies within one power grid. So it's assumed that all the nodes carry similar ENF fingerprints. And in order to test the ENF random nature, we used correlation coefficient to measure the similarity of two signals. So we carried an experiment to collect 200 hours of ENF recording from the power grid itself to test if there are any fluctuations which are repeating over time. So here is an heat map of 200 hours of ENF recording using the correlation coefficient. So correlation coefficient is nothing but a measure of similarity. It varies from -1 to 1, 1 being the highest similarity. So on the diagonal, you can clearly see that for the first 1 hour and the first 1 hour on the x-axis and the y-axis, all the diagonal elements exhibits the highest similarity. Everything else, nothing. That means like a particular section or segment of ENF recording fluctuations does not reappear again. So this is a clear proof showing that the true random nature of the ENF signal and the difficulty it has in predicting any kind of ENF, because the factors that affect in detecting ENF or predicting ENF completely depends on how the power supply is demanded or supplied over time. So this is our overall LEFC system design. So there are multiple parts to it, starting from the edge where the camera is actually deployed. So the edge is responsible to collect its own audio or video streams and estimate ENF from its recording. Once the ENF is estimated, it broadcasts the ENF signal which it estimated to all other participating nodes in the network. So basically what happens is there is a committee, elected for each round. So these are the validators. All these validators collect the broadcasted ENF signal from all the nodes. And as a result of this, all the ENF signals are aggregated and a unique ground truth ENF signal is estimated from all the signals. And from the ground truth ENF signal, each node is verified based on what the ENF signal they broadcasted. Now we can again use the correlation coefficient as the measure of similarity to test the similarity between two signals. And the correlation coefficient also allows to localize exactly if there is any mismatch in the ENF signal. So the whole process of collecting the ENF broadcast signals and electing a ground truth ENF signal for each round is the consensus mechanism we have designed as proof of ENF, and I'll be describing the proof of ENF. So as I said, like the whole primary task of the consensus mechanism is to conclude on a ground truth ENF and also to verify if the transactions are coming from a legitimate source, along with the timestamp verification and participation. So once all the ENF signals broadcasted are collected, an ENF score is calculated using the crumb aggregation rule. So using the square distance technique. So the scores are collected for each pair of ENF, and the minimum score is removed from the scores, and that is used to decide which one is the ground truth ENF. So what the crumb aggregation rules allows us is to provide more Byzantine resilience to the system. So let's assume if there are F Byzantine nodes, or also known as the malicious nodes. If there are, for at most F Byzantine nodes, there should be at least 2F+3 participating nodes in the whole network. So let's say if there is 1 Byzantine nodes, then there should be at least 5 nodes in the whole network for the whole system to work perfectly fine. So as I said, once the ground truth ENF is estimated, Then it is used to validate each and every single node. So once the ENF is estimated from the ground truth, this allows to localize exactly where, if there is any mismatch, to find like exactly where it went wrong. And like I said, a correlation coefficient varies between -1 to 1. We need a threshold to decide if there is a mismatch or not. So based on our experiments, we concluded on a threshold of 0.8. So using the threshold of 0.8, we are able to say if there is any mismatch in the ENF or not. And also the comparison between the ENF signal also depends on the length of the ENF signal. So also in order to make the detection real time, we have adopted a sliding window algorithm. So for the description of the sliding window, what we use is excuse me. So for the sliding window for attack localization, in order to able to like estimate ENF at real time, we use different window sizes as well as the shift sizes. So we used typical window sizes of 10 seconds, 30 seconds, and 60 seconds. And as the window is slided over time, we are able to like select the window, estimate the ENF, slide it over by 5 seconds, and repeat the process. So this allows us to like estimate ENF close to real time. Now, so, and also we have tested like which is the best window size to work with. So from what we tested it on the scale of correlation coefficient. You can see the window size when it is smaller, the number of false positives are higher, and slowly as the window size increases, the false positive starts going down. And here is a very clear depiction where the false positives are very less. For the comparison of like different sliding windows, what we've done is we've collected 2 parallel ENF from 2 different devices and compared them with like time lag. So once they are truly matched, you will see the highest signal correlation. And as they start to mismatch again, like start to introduce the delay, you will see the correlation coefficient going down. So that's what happened here. Since the window is really small, even tiny fluctuations are very sensitive, and that results in higher false positives. And as the window size grows larger, there are more frequency fluctuations you can include within one window size, and that allows us to like more localize exactly on which ENF signal to target on. So from the experiments, we've concluded to use a window size of 60 seconds and a shift of 5 seconds. I'll explain like how 5 seconds is helping in the scenario. So also in the figure D, you will able to see from the peak, there are like plus or minus 6 seconds of additional time delays which can be used, which is above our designated threshold. From this, we can also say that the system is also resilient to some network congestion delays. Let's say if any broadcast is slowed for any reason because of network congestion, what happens is it is able to tolerate those additional seconds of delays. Now, we have tested our network on different types of attack vectors, and especially for audio deepfakes, we have used a software called as Descript. The software allows us to train a targeted voice with as little as 10 minutes of source recording, and we are able to generate the source voice using just text-to-speech software like at real time. For video deepfakes, we use Deepfake Live. So this software allows us to like generate real-time facial reenactments on using any source actor. And the third kind is the frame forgery attacks, where a particular set of frames are rearranged. Since both audio and video carry ENF fingerprints in form of like embedded electromagnetic induction in audio recordings and in the video recordings through illumination frequency under the artificial light. So we've tested both audio and video recordings, and to test our theory for edge computing devices, we also tested it on like low compute devices to test how fast the consensus rounds are. So we used a low computer laptop as a monitoring server for our permission network. And for our each nodes, we've used Raspberry Pi 4 in order to use the low computing power restrictions we have to estimate the NF and collect the NF proof. Since there are multiple stages in our LEFC system design, I want to say show the time complexity for each one of the stage. For the first stage, let's say like we have an ENF vector of size D, which as just mentioned, we used a typical size of 60 seconds. And for a committee size of size K, size K can be both all the participants, maximum of all the participants in the node, in the network, or it could be a randomly selected number of committee members for each round. So assuming the size is K for the validators for the broadcast. So for the first stage where the ENF signal is broadcasted, the time complexity is big O of K, the transaction verification is big O of 1, and the one after that, for the final PO ENF consensus algorithm, the time complexity is big O of K squared D. Here the time complexity could increase with K being larger, like for a very, very large network. So we have produced some latency for a varying number of validators. Here you can see for a very small number of validators, the latency is really low. But once we have like up to 100, more than 100, you can start to see the latency going up. That means for an IOVT network for approximately 100 nodes, the cumulative time latency is like less than 2 seconds, which is still tolerable. That's why we've also added a shift of 5 seconds in order to accommodate the delay of 2 seconds of the latency of 2 seconds, so that the system is close to real time. Now, in order to demonstrate like what happens for each round, that is 60 seconds of recording, we've demonstrated it for over 1 hour, where we have added Byzantine nodes starting from 15th minute to 45th minute. So you will see, like, as I mentioned, ENF score is calculated for each node. So for a Byzantine node, which does not have proper ENF signal, the ENF score is pretty high. So you will see here, starting from 15th minute to 45th minute, there is one BFT node which has consistently higher ENF score. To judge how the ENF signals are different, you can like zoom in to one particular round, and you will see that I've reduced the number of nodes here for more clarity, but you will see all the honest nodes follow a particular pattern where like one signal has small delay, but there is one BFT node which is completely different. It has ENF fingerprint, so it varies huge, and hence the ENF score is pretty high. So this test was conducted with a BFT rate of 0.2. That means like 20% of the participants in the network are Byzantine nodes or malicious nodes. Now we know, like, in a particular blockchain or a distributed system, the majority of people who conclude on a particular decision affect the outcome. So we also tested like how many Byzantine nodes can be able to influence the ENF score. So we've tested with varying number of byzanting nodes to see like how the final ENF score is affected. And here you will see like for like really small, let's say for PF for node 10 nodes, there is one Byzantine node, then ENF score is pretty high, and the honest node is really slow. And this is the average for like the average ENF score range. But as the PFT rate increases, the range keeps decreasing and the average honest node range keeps increasing, and it reaches a point where a typical 50% attack on a distributed system can be either way, like it could point towards the honest node or Byzantine nodes. So we are able to see like the proposed system is still tolerant of the Byzantine node all the way up to close to 50%. Now for the discussion, the proposed system works for audio and video recordings made in indoor environment, which is the general scenarios where the IOVT cameras, smart cameras are deployed, because audio could carry fingerprints from background hum or electromagnetic induction from directly being connected to the power grid, or video recordings could carry ENF fingerprints from artificial light, which is very common in an indoor environment. But for an outdoor environment, the video doesn't have any artificial light source to carry the ENF fingerprint, but it could still rely on audio recording. So we can have like a dual channel authentication and have like more robust techniques by combining both of them. And as I mentioned, the system is still susceptible for more than 50% attack, which is common for all kind of distributed system. But our system can still detect malicious node if there are at least 60% honest nodes. To conclude my talk, we've presented today a proposed system of LEFC system, where it is used to detect compromised and malfunction nodes in a edge surveillance system. The kind of attack vectors which it was tested against are like audio video deepfakes and also false and forgery attacks. We've detected the signal, we've detected the malicious node using electrical network frequency as an environmental fingerprint, which carry both spatial and temporal fingerprints, and which is very helpful for authenticating multimedia recordings. And design consensus mechanism allows for distributed authentication without relying on any central system or without reading any kind of external references. Okay, that's it for my talk. Thank you very much.
Thank you, Anubhav. Thank you, Dheeraj, and for your interesting presentation. And let's see if we have any questions there. No, so far I cannot see any question in Slack. But any question from participants here? No. So I think the talk is very interesting, and given that the attacks are quite important to consider for the large-scale IoT systems. So I have a very quick question for you. Like, how do you provide authorization for entities in your system?
What do you mean authorization?
Because you have authentication, right? You said the lightweight authentication systems for the for this. So how do you actually provide authorizations? How do you know that actually the users are who they are claiming to?
So the authorization is through the embedded signal, which is through the multimedia streams. Since the deployed system are actually for the devices like camera nodes or the audio nodes, by default, most of the multimedia recordings which are made, they carry these signals through one or the other form. For example, in video recordings, the signal is embedded in the video through the artificial light. Like for example, like right now in my video, there is electrical network frequency signal embedded through the artificial light I'm in. So through this, you just estimate the signal out of this video, but from the exact same time instant, someone else within the building or within the region who has a similar presence and has some kind of multimedia recording made, they also have similar ENF fluctuations. So we don't depend on external signal being provided. It's the signal which all the devices record at the exact time instant that are being estimated at the edge, and they are being sent into the consensus.
Okay. Okay. Thank you very much, Dheeraj. So I guess we do not have any further question for you. So we can move for our next presentation.
Sure.
So our next presentation, before we move forward for lunch session, the talk title is Blockchain and Machine Learning Based Framework for Efficient Health Insurance Management. And talk will be delivered by Anubhav. Anubhav is a PhD student in the Department of Electrical and Electronics, BITS Pilan, India. He has worked on the design and verification of hardened IPs and FPGA fabric related to artificial intelligence, high-speed data transfer, video codes, IPs for embedded vision. His expertise is in implementing hardware-software co-design solution on FPGAs and providing hardware acceleration to the embedded applications. Anubhav is a recipient of the prestigious KVPUI scholarship given by IISc Bangalore, India, and Sakura Science Scholarship given by Japan Science and Technology Agency, JST. Anubhav was also selected for the International Linkage Program with Hiroshima University, Japan, to present Birla Institute of Technology and Science, India. So now I welcome Anubhav to present your talk.
Thank you so much, Shantanu, for the kind introduction. And I would like to congratulate other participants for giving such a nice presentation. Thank you so much, Dheeraj. I would start sharing my screen. So Adit, who was the main person behind the paper, the first author, he has his final end semester exams going on, and suddenly in India it has got really cold, so Vinay sir is little sick, so I'll be presenting on their behalf. This is my first time presenting, so please forgive me for any mistakes. So this is the title of our paper, a blockchain and machine learning based framework for efficient health insurance management. The work has been done by 4 people: Adit, Anubhav, Vinay, and Biplab sir. So this is an overview of our presentation, what I'll be going through: abstract and keywords, introduction and our contribution, then the related works. Then we'll come to the main crux of the paper, which is our proposed model. Then we'll come to the numerical analysis and results, and finally the conclusion and acknowledgement. So having a health insurance is important for everybody, bearing in mind the increasing medical costs. Medical emergencies can have severe financial and emotional impact. However, the current settlement process is excessively lengthy, making it tedious. The result in policyholders, the result is that policyholders not being able to successfully make a claim with their insurance company. So in this paper, we focus on developing a fast and cost-effective framework based on blockchain technology and machine learning for the health insurance industry. Blockchain is capable of removing all third-party organizations by forming a smart contract, making the entire process more smooth, secure, and efficient. A ridge regression model is used for computing the premiums optimally based on the total amount claimed under the current policy tenure, along with several other factors. More on this, I'll discuss as we go further into the discussion. A random forest classifier is applied for predicting the risk that helps in the computation of risk-rated premium rebate. So beginning with our introduction. Just give me a quick moment. So with the advent of COVID-19 and various other rising instances of diseases, the cost of healthcare services has been increasing at an alarming rate. In the current insurance system, the small and consistent premium has taken a price hike. The insurance industry spend a lot of money on administrative and marketing, which comprises of commission to brokers, advertisements, brochures, etc., which are eventually recovered through the insurance premiums. There are a lot of issues in the classical insurance process. For instance, the insurer has to complete a lot of documentation and provide proof of the loss value. The broker causes more delays and expenditures. Knowledge sources are diversified and inconsistent, such that the insurer has to seek additional information in this. So in this paper, we propose a blockchain-based solution to the above problems to provide health insurance services that can be cost-effective as well as efficient. The paper aims to exploit the blockchain technology to find solutions to our problems because of the various key features it pertains to by the use of smart contracts, automating and speeding up the tasks of client registration, policy issuance, and claim processing. It makes use of decentralized distributed ledger that is capable of eliminating all third-party authentication. Fraud detection becomes easier as it is immutable and transparent. A transparent ledger of changes preserves the integrity of the document, which creates trust in the asset. So following are the major contributions which we have in the paper. We propose a peer-to-peer network of hospitals and policyholders that will bound in a smart contract. The smart contracts will also hold the claim histories of each user for the premium calculations of the next term. The ridge regression is used to predict the premium. Claims are sent directly by the admitting hospital, which will be approved by the smart contract. Risk is predicted with the help of a random forest classifier. If the amount in the contract is sufficient for predicted claims, then a rebate may be given to all policyholders based on their predicted risk. Furthermore, a risk-rated premium rebate model for premium calculation of the next term also has been proposed. An experimental result shows that the proposed method is cost-effective and fast in comparison to the existing traditional methods. Before I dive into the our proposed model, I would like to go over through the related works very quickly. So in 2017, the company by the name Etherisk, which is a German insurance company, collaborated in building an open source framework focused on decentralized insurance applications. So they have a site. Feel free to just quickly showing you this site. So it says make insurance fair and accessible, decentralized insurance protocols to build to collectively build insurance products. Next, we have Venus and VTrust, which are two US insurance companies that by the end of 2017 developed a blockchain-enabled homeowners insurance system. We have pointed in our references. Please feel free to take a look at this site. Then Raikar and Mazumdar discussed exploring blockchain to remove the third-party organizations and automating insurance processes. You can see their paper. Then we have a peer-to-peer blockchain model, which has been used in various fields, such as traffic jam management, biometric and security mechanisms in parking systems, data marketplaces, data offloading, and smart cities. There are many other related works, and in interest of time, I would like to skip this. Please feel free to go through in our paper. So this is our proposed model, the flowchart of our proposed model. Now start from this point. Consider a person P who registers into a blockchain network with the required details. A regression model is applied to predict the premium for the health insurance policy at this point. When P gets admitted into a hospital H completes all the documentation for the claim processing and automated claim settling is done. On completion of a term of the policy, a random forest classifier is applied to calculate the risk of an individual, which is passed as a parameter to the risk rated premium repaid mathematical model to calculate the new premium. This whole flowchart represents all this. I'll keep on referring to this flowchart. So the first aspect is of ridge regression for premium prediction. So in order to help the algorithm converge to linearly separable data and minimize overfitting, an L2 regularization adds a penalizing term to the squared error cost function, which you can see here, where X is a design matrix and alpha is a hyperparameter. Since a high variance was observed in the baseline model, ridge regression was considered to be appropriate. The dataset being used here is the US health insurance dataset, which has 1,338 rows of insured data and no missing or undefined values in the dataset. You can find this dataset on the Kaggle website, which is described here. So for the initial pre-processing, we checked the feature of the dataset to convert categorical features into integer encoded vectors and Boolean features into binary. The feature vectors comprised of these 6 elements after pre-processing. Moreover, the features were normalized to bring all the data to the same range. The details of input and output parameters are given in this particular table. The final output is the premium amount, which we have come before forming the smart contract. Next is applying a random forest classification for risk calculation. So on completion of a term, the risk of the policyholder is evaluated based on the various parameters such as family history, insurance history, employment history, medical history. You can refer to this table too. A risk factor of an individual insured is calculated to provide a rebate in the next term's premium. The dataset being used here is the Prudential Life Insurance dataset. This data is split into training dataset is split into training and testing sets, each with approx 53,000 and 6,000 rows respectively. For pre-processing, we eliminated the features that were used solely to identify the beneficiaries. Categorical features were factorized to be represented in numeric vector. Moreover, a new feature containing the number of medical keywords was also introduced. Now comes the part of risk-graded premium rebate model for premium calculation of the next term. So we use the concept of risk-rated premium calculation to compute a rebate based on the premium. This has been adopted from the reference 6 in our references. PX here is the premium of the current term, and the premium for the next term is called EX, and it has to be calculated. The risk X is covered under the medical policy. The claims that we got from X are distributed as a random variable, and its cumulative distribution function is given by f of X. So let the current total amount in the smart contract be C. On the scale of 1 to 8, the risk factor equal to 1 corresponds to the claims of the full amount insured, which we are assuming we're letting that variable to be I, and risk factor 8 corresponding to no claim. The total amount spent on expected claims would be represented by T from this particular equation, where N is the number of policyholders registered in the contract and RI is the risk associated with the individual I. So next we calculate the extra revenue that is being collected in the contract, which is given by the equation C, which is the current total amount plus the amount which is the total amount collected from premiums if no rebate is given to those particular individuals, and T, which we calculated above as the total amount spent on the expected claims. So the risk rated premium is calculated this way for each individual, and then a rebate is provided from the extra revenue being collected from the policyholders. The risk adjusted premium based on the Escher's principle is given by this particular equation, Px from integration from 0 to infinity 1 minus f of x raised to the power 1 by r dx. And the risk rated premium rebate is finally calculated as Px minus small r upon capital R into ER, where ER is the extra revenue. So we have done a simulation, and I would like to show you the code which we have for the different Python scripts which we have written. So this is for the initial premium, the calculation of the initial premium. So all these equations have been what I've gone through have been captured in this particular notebook. In interest of time, I'm just skimming through it, and this is how we've got our results. And risk calculation, which was our section 3.2, which is the second data set, the potential life insurance data set, which is giving us the following. Over through the results shortly. Also, I would just want to show you that we used the SmartPy library to which is an intuitive and powerful smart contract development platform from Tezos to help us code in Python. So the simulation settings looks something like this, that the blockchain is used to make the peer-to-peer network, and a smart contract is deployed on the blockchain network as the first node that cannot be changed. Smart contracts are written in Python language using the SmartPy library, which can be deployed on the Ethereum network. To improve the performance of the rate regression model, we used the polynomial feature of degree 7 and took the value of alpha to be 3 to obtain the best results. The training and testing set was split into a 3:1 ratio for ridge regression. And in the risk calculation model, the training and testing sets are randomly split into 9:1 ratio. The number of trees in the forest is set as 50, and the number of features to consider for splitting is 75. The minimum number of samples at the leaf node is 8, and the maximum depth of the tree is 50. The minimum number of samples required to split an internal node is 40, and bootstrap is kept as false. So these are our simulation settings. And we have the results, which shows that the histogram density plot for the random forest classification, which is showed in this figure 2. So for premium prediction, the root mean square error, the mean absolute error, and the R-square scores have been calculated. The above mentioned values have been reported for the training and testing sets in the figure 3. Out of the various regression models tested, ridge regression with the use of interaction terms gave the least root mean square error and the highest R-square value. In the risk classification problem, we calculated the accuracy, the root mean square error, and the mean absolute error to assess the performance of all our models as shown in the table 3. The low accuracy is attributed to the large number of classes, and the predicted classes fall in the close range of the actual value, which is shown by the low MAE. So these were the two models executed on the random forest. Coming to the conclusion, the two major problems in the current insurance system, slow moving and expensive, has been solved in the proposed blockchain-based health insurance model. The results show that our proposed model is reliable, cost efficient, and fast. The whole procedure of claim processing with a fewer number of mediators and smart contracts helps to make the procedure fast, and risk-rated premium rebates help to motivate people with lesser claims to continue with their policy. It also stopped the extra revenue being generated in the current insurance system by distributing them in rebates rightly based on the risk. Results show that out of the various multi-class classification, machine learning techniques, random forest classifier gave more accurate results. Finally, I would like to say thank you. and acknowledge the work which was supported by SERB's Asian India Collaborative R&D scheme. Thank you, everyone.
Thank you very much, Anubhav, for your interesting presentation. The topic is quite useful nowadays, blockchain and health insurance management. And it goes beyond health insurance, and it is quite useful to have now blockchain and parametric insurance as well. So let's see if we have any question in Slack, but no, I cannot see any question there. So any question from online participants here? No, I cannot see any questions here. So I just have one question for you. You know, in this kind of insurance, it is quite important to have the integrity of information, and how do you measure that the value that are coming from the different sources, they are trusted. So how do you actually achieve trust in your framework?
Thanks, Shantanu, for the question. And the trust, actually, the blockchain which we have. So I'm actually more of the Python coder who coded all this part, and Adit was, and Vinay sir has done the blockchain and that part. So I we can actually revert back to you through the official mail, and I won't be the instead of confusing, I'll prefer to let them answer this question.
Okay, so thank you. We can communicate maybe over email. Once again, thank you, Anubhav. And this concludes our first technical session. And now we are having lunch break from 12 to 1 in Portugal time. And we'll again reconnect ourselves at 1 p.m. Portugal time. And we are having a series of very interesting topic and very interesting talk from 1 to 2 Portugal time about practical implementation of blockchain and IoT. And the presenter is Aljosa Beza from BlockLab. So I would like to say thank you once again for all the participants in this session, and hoping to see you all in our next session, which is 1 p.m. Portugal time. So thank you very much once again.
Thank you, everyone. Thank you, Shantanu.
Hi, Volkan.
Hello. Hi.
Hi, Volkan. Hi, Alusha. Can you hear me? This is
Hi.
Hi, Gauri.
Hi, how are you?
Very good.
Shall we start?
We'll just have to make sure it's already streamed live on YouTube. It looks like it's not streaming yet.
Yes, we are live.
Oh, okay. We are live now. All right. Okay, great. Yeah, please go ahead, Volkan. Yeah.
After the lunch break, I should probably say good afternoon. Welcome to the BlockSys 2021 virtual workshop. My name is Volkan Dedolu. I'm from CSIR Australia, based in Brisbane. I'm very delighted to chair my speaker. Alyosha is the director of Block Lab, which develops blockchain solutions for supply chain and energy industry. Before Block Lab, he held a number of senior and C-level management positions in IT and supply chain management within companies such as Kuehne+Nagel, General Electric, and Nokia. He is also a senior researcher at the Lecturate of Supply Chain Finance at Windesheim University of Applied Sciences in Netherlands, and also visiting lecturer at the Marshall School of Business, University of Southern California, where he co-teaches the course Emerging Technologies in Supply Chain Management. He's a co-author of the book, Blockchain and Supply Chain Concepts, Strategies, and Practical Applications. Alyosha holds a master's degree in quantitative business economics from Erasmus University, and his specializations include blockchain, IoT, algorithms, logistics, and supply chain management. The application of the IoT and blockchain can help companies to observe, track, and monitor products and automate activities and processes within their supply chain. In this session, Alyosha will present a number of potential use cases for IoT and blockchain in global supply chains. Before I pass it to Alyosha, I want to remind our audience to send their questions on our Slack channel, please. Thank you, Alyosha.
Thank you, Volkan, for the introduction. Let me see whether I can share my screen. Let me see. There is something not working. Let me see. Open system. I think I need to, my security settings are for not suitable for Zoom. It's very nice. Just a second, please. So, okay. I need to leave the meeting and log in again. Apologies for this.
Sure.
All right, let's see whether it works now. Apologies for this. Yeah, it works now. Perfect. Okay. Let me switch to the bigger screen. My background is I'm a supply chain aficionado, so I will be talking more about the practical use cases of blockchain and IoT. But before I start with that, I think it's good to share a little bit of background on what's happening in the world of logistics and supply chain. A couple of years ago, I probably would have needed a very large set of slides to explain what supply chain management is all about and logistics is all about. But nowadays, with all the problems that we face with goods not being on time, empty store shelves, I think everybody has some first-hand experience on what a supply chain is. Whether that's a very pleasant experience, I leave that I'll leave that for everybody to decide by him or herself. But supply chains all of a sudden are becoming, well, I would like to use the word sexy all of a sudden, and that's despite the fact they have been around for hundreds and if not thousands for years. But there's a lot happening right now, and I before I start with talking about the particular use cases, I think it's good to set the scene a little bit of what's happening. When I look at a supply chain, I normally see three flows, and the physical flow, that's containers, that's ships, that's trucks, that's products, that's things that if you drop it and it falls on your toes, then it hurts. The financial flow is everything related to the monetary side of things, most payments, but in order to get to payments, there's an enormous amount of paperwork and information exchange, and that brings us to the data flow, because the data flow ties the physical flow and the financial flow together. Because the goods are moving from the seller to the buyer, and money flow is going the other way around, and the financial flow is there to ensure that is somehow tied together. Because at a certain point in time, the responsibilities of the seller ends, and he has done what he has to do according to his contract, and then the money needs to go the other way, and then it becomes the goods change ownership, and that is all governed by changes in statuses, changes in documents, and that is all captured in the data flow. And we've seen quite a lot of changes in all three aspects, actually. In the physical flow, containers, without this big metal box standardized, we wouldn't have had our global supply chain and worldwide trade. And it also resulted in enormous economies of scale, because you could decide to produce for the rest of the world in one single location. It has also some subsequent downsides, actually, but we'll get to that later. New management methodologies like Lean, Kanban, etc. And what we also see is the fact that goods are not only sold via shop, but also via websites. Financial flows, I think somewhere around 2017, 2018, we hit the limit of globalization, primarily because of political changes, because of that, there's changes in the financial flow, also negative interest rates, and the fact that a lot of these financial flow processes are extremely outdated. I'm going to tell you a short story about how a well-known bank identifies whether a bill of lading, which is a document of title and therefore also a document of value, how they assess whether it's real, and that is by feeling, or whether it's the original bill of lading, and that's by feeling touching the document and feeling whether they can sense the indent of the pen that signed that particular document. And this is anno 2021. So it's kind of scary that these are processes going on still in this time of age, but that's what is the case. And data flow, yeah, we've seen rises of all kinds of platforms, Amazon, Alibaba, and also cloud computing really changed that aspect. So then when you add COVID to that, things start to get even worse or more challenging, so to say. And I told you about the bill of lading, where people just feel with their hands whether it's real. Well, in order to get to that person to feel that can touch it and to sense whether it's real or not, you need to fly it. And when COVID started, all of a sudden there were less flights. So documents didn't really get moved from, for example, China to the Netherlands at all, because there were no planes taking the documents there. Also, people were afraid to start touching these documents. So because of being afraid of contracting COVID. This resulted in things that were already going in exploding the problems that we already had in terms of the imbalances with in containers. We produce in the Far East and we consume in Europe and in China. And we had a shortage of containers and vessels not being able to offload their containers in various ports in the world. And a good example is that basically this was in August of this year. In Germany, the construction industry just grinded to a halt because there were no raw materials. Companies also saw big changes when it comes to the way people buy their products. Everybody experienced the huge queues in their street with DHL, with a DHL van, a UPS van, a FedEx van, and kind of local parcel delivery companies, because everybody was ordering online, and that was not done in a very smart way, because yeah, I've seen pictures in Amsterdam where you had really literally the 4 delivery trucks of the 4 different big delivery companies in a single street delivering in the same house. So it's a little bit scary. So there's what COVID highlighted is really that our current supply chain, the way we currently run supply chains, yeah, that's not something that is sustainable. That is, and it simply cannot continue going on like this. So what you have is really a perfect storm, and I took some clippings from various articles, and there's really a lot happening right now in logistics, and one of the things that I think is very interesting and would have not happened without COVID is this one in the middle, where basically the G7 countries say, you now have 12 to 18 months to get your act together and start digitizing global trade. Now, the biggest culprit in digitization is actually not the companies, but it's the authorities and the governments, because they run on old school mainframe systems that are difficult to change and difficult to connect with. But I think this ambition really highlights the importance of emerging technologies will play in the coming years within the world of supply chain. And I don't think the 12 to 18 months is extremely realistic, but it definitely is good to have ambition. So, and how did I get, as a supply chain person, interested in blockchain? And that is, it started with my master thesis that I did at Erasmus University in 2002. And that was, I started to look at how supply chain management was implemented in software solutions. At that time, you had advanced planning systems, I2, but also SAP already had their supply chain management, supply chain planning applications. And one of the things that I found during my thesis was that these models that these systems implemented, they work extremely well if you're a dominant member and you're highly centralized, because these models rely on all the data being coming to one single point, and then you run a couple of beautiful mathematical equations or formulas, and then all of a sudden you have your optimum order quantity or your optimum inventory. But it's also not how most supply chains work. Most supply chains are highly decentralized and require collaboration and coordination between a lot of different parties. Mind you, this was in 2002, 2003, so nobody had heard of blockchain. And when I started hearing about blockchain and what it was meant to do, and mind you, this was 2013 when I first heard of blockchain, and at that time you only had Bitcoin, at least in terms of protocol that was out there and working. For me, what really got me hooked was the fact that, wow, we now have an IT architecture that supports decentralized coordination. And that is how I got into blockchain. So I came from supply chain and then started to look into this. For me, decentralization and supply chain management, and how do you coordinate the process of getting a container from China to the Netherlands, that has been, well, basically what I've been working on with BlockLab since the last 5 years almost, and also has been my personal interest for more than that, and also my research interest, because getting a container from China to the Netherlands requires 29 different parties that have to collaborate together, and some of them even don't have a contractual agreement with each other. So it's a very decentralized and system where nobody, in some very few cases there is a dominant member, but in general most supply chains are basically run by equals and require cooperation and coordination. So just to give you an example of the parties involved, this is a more graphical way of looking at it. So you got banks that involved in the financial flow, but also insurance companies. You got all kinds of logistics service providers. Some of them have real assets, real boats, real containers, but some of them are just information brokers or information handlers, like freight forwarders who don't own a boat, but they make a booking on behalf of the seller on the boat. So it's and then you have the information flows. In this case, we're talking about invoices, but it can be there are so many different documents. So but this serves as a kind of conceptual representation of your average supply chain. And with that, it's not transparent. Most parties don't know what's happening before them in the chain or after them in the chain because of siloed systems. There's a lot of paper, extremely fraud sensitive. You can imagine if the only way to tell whether the document is real, you have to touch it. And these frauds are quite elaborate, and they range into they sometimes become so big that you're talking about billions of dollars of fraud. One of the big Dutch banks, ABN AMRO, actually had to sell their trade finance activities because they lost so much money because of these frauds. So it's a real problem. It's something that people in the supply chain deal with on a daily basis. It's very time consuming. So what you actually need is a way to integrate all that. And I like to use the idea of the universal adapter. That we all know that when we travel to another country, probably the sockets won't match. So you need something that does in one country or the other. So basically, that's what you need. And I think that blockchain, in combination with other emerging technologies, and IoT is definitely one of them, can play a role. And what I've done is I've taken a look at how blockchain and IoT somehow work together and can work together within different supply chain processes. And for that, I used the SCORE model, which is a standardized model developed by a supply chain a standardization organization that defines the various processes within a supply chain. And there are a couple of core processes, which are plan, source, make, deliver, return, and enable. And within these core processes, you have various sub-processes. So, and the good thing is that also they looked at, okay, what are important metrics involved within these different sub-processes. So if you improve process, for example, SP 1.3, if you can make improvements there, what kind of important supply chain metrics will be affected if you make changes in there? And I think there the main cases is that if you combine IoT devices and also add blockchain to that it allows data to be tracked at the source, and so not in forms of documents that have been entered by a custodian at a certain point in time, but really get data from the source in a way that it is in line peer-to-peer with how supply chains operate. So there's peer-to-peer data exchange and not first send everything to a central point and then send it back again. And also to ensure that it is privacy preserved to prevent that sensitive data can be shared with everybody. Yeah, that is, I think, where blockchain and IoT come together from a functional perspective. Another important aspect is using blockchain to provide a common frame of reference over all these different siloed systems. Because that is also one of the main challenges, is that how do you know that one, and a good example is, for example, a bill of lading. How do I know that the bill of lading I received is exactly the same as your bill of lading? And is there a way to verify that? That can be quite easily done using hash functions, and by that you can provide not only you can not only prove that it comes from a certain origin, and that it is really a party that is supposed to issue that particular document or asset, but also you can check that documents have not been altered, and you can also, once you have that sorted, you can also turn these documents into tokens, and especially for bill of lading, that's quite relevant, because then you can transfer ownership of cargo by means of a token and not by means of a document. So another interesting point, I think, is also and that is the ability to build in sensors, for example, and use data from sensors in containers, and that's, I would say, already quite common. At least location is quite common, and also some conditions. But I think there can be more advanced applications. For example, to battle fraud. And a nice example is that this year there was a fraud case where there were a couple of a Chinese company bought copper from a Turkish company, and they had been delivering on a regular basis copper, and at a certain point in time they again placed an order with this Turkish company. The Turkish company said that they sent the container. The container arrived in China, the container was opened, and instead of copper bricks, there were real bricks in there. They were painted even in the color of copper, so it's quite elaborate. But you can imagine that if you have sensory information that checks the content of a container, the chemical composition is obviously different of the air inside of a container, whether it carries bricks or whether it carries copper, real copper. So you could use that in order to prevent fraud. And a case that at BlockLab we built a blockchain platform that is about to go live in the next couple of weeks. And we did a couple of pilots, and one of the interesting pilots we had was also using blockchain and IoT devices. And we were using them for transport of a container from the Netherlands to South Korea. And the container contained milk powder, and they had a lot of quality complaints from the client in South Korea, and they really the company that we work with, they really didn't know why, because they said, well, we put it in a container, a reefer. It's cooled. There's nothing wrong with the reefer, and yeah, then it's shipped, and then it arrives at the client, and then they open it, and then they say that yeah, apparently the humidity or the temperature was too high, or and that deteriorated the quality of the milk powder, and they simply couldn't understand what was going on there. So we said, okay, let's do a trial and let's bolt on an IoT device. And it was not even a very fancy one. It was just one that only measured location. So at a certain point in time, the container left, and we got a call from the client, and they said, well, your system is broken. And we're like, okay, well, yeah, could be. It's a pilot environment. It's not a full enterprise-ready solution. So yeah, we might have overlooked something. But what is the problem? Well, they said, well, you know, we got a quality complaint from the client, but your system still says that the container is in the port. So how does that work? And we were like, oh, okay, let's try to find that out. So we asked somebody in South Korea to go to the port, and yes, that container was indeed there. But they also noticed that the container was opened, which was against the instructions of the client, and that the local trucking company just for whatever reason opened the container, put in a couple of bags, and then drove these individual smaller portions of cargo one by one to the receiving company. And of course, during that trip, yeah, the quality of the product deteriorated. And that was just a very simple use of linking a asset, in this case, a container, to an IoT device. And there are a couple of other, I think, interesting applications where if you can that allow blockchain and IoT to work together. I think if you look the way to and it's not only to prevent fraud but also to ensure that processes of reconciling systems. So I have an order for 100 and making sure that actually these 100 products are actually received, and that it's not a very laborious and complex process to align these systems together. Again, there you could make use of the combination of blockchain and IoT. One of the interesting things, I think, is that if you look at all the different score processes, and I had some debates about that with some people, is that if you look at all the score processes are captured, I think, when you use IoT in combination with blockchain. The only exception is really the production process, at least according to my own research, and that's and that is because blockchain and IoT let me put it differently. You could use IoT in the production process, without a doubt. But using blockchain in a make process that is normally within the four walls of your own company, to me sounds always a little bit strange, because blockchain is used in a trustless environment, and when you build or when you make a product within your own four walls, that's hopefully for every company that's a trusted environment. And I still don't see the point in using blockchain within the four walls of a company. Blockchain and a warehousing system that uses blockchain is probably not the right implementation or right use of technology. It is much more in the processes that are outward facing, like sourcing or distribution, where I think blockchain makes sense, and also then because of that, the combination blockchain and IoT makes sense because of that. There's a number of enabling processes, and there you can really see the use of blockchain in order to speed up processes and really look at ways to ensure that data is validated and accurate, and also real time made available. So I think that's where blockchain and IoT can make very good sense in the enable processes. I will share the slides later on, and so that can be used for further reference. What I think is also quite interesting, because we now really talked about all the functional aspects. So yeah, how can it make how can blockchain and IoT work together and solve logistics problems? But I think there are also a couple of interesting non-functionals where blockchain and IoT can really be of value. I think security is definitely one of them. One of the things, one of the use cases that is quite often described is a container that books itself around the world. So it's basically the container is equipped with an IoT device that tells you where the location is, and then tells you where it needs to go. And it can also tell you what kind of service it needs at what given point in time. So I need a truck to take me from where I am right now to the container terminal, and I can also prove that I have all the necessary documents available in order to be allowed on that container terminal. Now, that can be done using that is technically already possible, although I think that the current structures that are used to operate IoT devices are very, they all have, they're very centralized systems, and because of that, a single source of failure, and blockchain could at least make these IoT devices more robust, and by making sure that there's a certain level of decentralization. I think in the agenda this morning, somebody from IOTA spoke, which I think is is a very interesting protocol that that can help increasing the security, and also ensuring that there's a unique identification of devices, and also to ensure that when you have machine-to-machine communication, that these machines trust each other. Often overlooked in a lot of technological implementations. You can build anything you want nowadays with technology, but yeah, you need a suitable infrastructure, I would say, for that. Because supply chains are global, and yeah, unfortunately, the wireless infrastructure is not as well deployed everywhere as as it is, for example, in Western Europe or the US. Yeah, there's quite a lot of so to say dark spots when it comes to access to reliable wireless infrastructure. One of the things that I think is a very interesting solution is helium. That's when long-range Wi-Fi meets blockchain, and it's getting quite a lot of traction right now, and it claims to have democratized long-range Wi-Fi for the masses. And there's also a cryptocurrency linked to it, and there's also a earnings model associated by if you provide or if you are one of the people hosting one of those helium modems. Also, scalability is it used to be the elephant in the room, because yeah, blockchain and IoT, it seems logical, but in terms of transactions per second, Bitcoin was not the right protocol to use in combination with IoT devices. I think advancements in protocols have been quite have been rapidly progressing. There's I earlier mentioned IOTA, but there are a couple of Ethereum is now working on layer 2 solutions, use of sidechains like Cosmos, and also other consensus algorithm than just simply proof of work. In my opinion, make the elephant already considerably smaller. And I think the potential of blockchain and IoT is becoming less of a technical challenge, but more of a what is allowed in terms of digitization. Can we get the infrastructure up and running? Can we get security organized? So I think the non-functional parts are probably more of a challenge than really what the technology can already do. And I think one other aspect is making use of blockchain only where it makes sense. I think over the last couple of years, there's been more realism of what blockchain can and cannot do. In the early days, it was a solution for everything. I think that over time we have learned, and that it is one of those toolkits, one of those tools in your toolkit that you need in order to be able to really develop solutions that can solve real world problems in the supply chain. yeah, that's my presentation. I'm more than happy to take any questions that have arisen.
Thank you, Alyosha, for the interesting talk. Yes, we have a few questions. Gauri has two questions. The first one is related to export-import control regulations. He asks, how is the regulator engagement at export and import points? Are they adopting blockchain-based systems for compliance verification?
Mm-hmm. Very interesting point. That is actually the our first service that we go live with, and we also signed the first 2 clients for that. And that is a fully automated customs clearance application that basically gets validated data from various sources. And at this point, we don't use IoT yet, but we do see possibilities of using IoT data as well in order to obtain validated data throughout the process. And that is basically a fully customs compliant solution that is fully digital, runs without any human intervention, as is it uses validated export data in order to create a import the necessary data you require for import, yeah, that together results in yeah, a fully digital customs declaration system. And so that is one of the areas where for import and export, for example.
Yeah, I guess that will also require countries working together, because in a global supply chain. Yes.
Yeah, yeah, it's in this particular, well, yes. Although in this particular case, it's business to business and business to government. So it's not necessarily to have the 2 governments collaborating. It's just that you need to be able to provide that information in a way that you're in line with what the governments require. And yeah, if you look at what is really needed, or let me put it this way, if I turn it around, how the process currently works is actually that when I export things from China, I have a packing list, I have an invoice, I have all kinds of documents. I print them out, I put them in a DHL pouch, then DHL comes to pick it up and delivers it to a customs clearance agent in the Netherlands. And this customs clearance agent starts entering that same data that was already available in China into the system. The only thing what they do is they classify the goods, which is difficult the first time when you do a new product, but after that it's very repetitive. So yeah, and I've spoken to quite a lot of government authorities, and they say, well, it's a bit strange that it works like this, because they're basically entering the same data that is already available on the export side. Why not just let the export party submit that data, and then we can get our money much earlier? So that is so I think it's a big step forward in terms of what is out there currently. Yeah, we one of the things that we're adding to it is using a digital proof of delivery, and that, with a bit of a stretch, that you could argue that that is an IoT device because it's on a tablet. People give a sign on it, a sign on glass, and then you get a longitude and latitude, so you can really prove that goods have, for example, crossed the border. And we're adding those kind of functionalities to it, and then right now those are separate systems. You do a customs clearance, and then somebody else does the transport. By having it all integrated into one single workflow, customs now also know that not only have these goods been declared, but we also know that these goods have been actually delivered. And I know it doesn't sound like much for technology people, but this is a huge step forward of what is currently available.
Yes, thank you. The second question is regarding privacy. In a cross-jurisdictional supply chain, importers and exporters will have to share data with multiple parties belonging to different jurisdictions. Are there any privacy concerns in such a context? Can you please comment on the privacy requirements for a cross-jurisdictional supply chain?
Yes. Well, privacy is I normally divide it up in two parts. One is because of legal concerns. So GDPR, and I don't know, yeah, that's something we have in Europe. And there are, I would say, equivalents in the rest of the world. Privacy concerns are quite, if you do not adhere to the law, then you got a problem and you get fined. That can be information about an entity, but it can also be information about a person working for an entity. That is very that is very sensitive and privacy sensitive information, just because the law tells you that this is privacy sensitive information. And the other aspect is, that is commercially sensitive information, and that because of it's commercially sensitive, there's also a privacy concern there, and that is if you like prices, if you put that out in the open for everybody to see, that is not that then also becomes a privacy concern, because you don't want that. The way we solve that in our own application is that the amount of data that we store on the blockchain is well, we don't store any transactional data on the blockchain. We just store a unique identifier that points towards that data. And by doing so, we can still make the transaction transparent to everybody, but you don't make the data itself transparent. And the communication between parties is not handled by our platform, but it is peer-to-peer communication between parties who will authorize each other access to certain documents or digital documents or digital assets.
Thank you. We have a question from Luke regarding the current implementations trials. Is there a company already implementing IoT blockchain tracking on cargo containers? If no, not really, does BlockLab plan on testing blockchain IoT onto containers?
Yeah, there are already a number of companies involved in using blockchain and IoT devices. One company, I know the Dutch market a little bit in that respect. It's a company called Varox that works on that. I know Austria, there's a company called Riddle and Code that did a lot of work on IoT devices and using them to track assets in general, but it could also be containers. At this point,
TradeLens as well.
Yeah, TradeLens. As far as I know, they have not gone into the development of hardware. So TradeLens is the software application. So they really do the blockchain part. But to my knowledge, TradeLens has not doesn't have its own IoT sensor that is linked to a container. That has to do with the fact that all the big carriers, they have agreed on certain standards when it comes to IoT devices. And the standard is based on Traxens, which is a French company, and that is partially owned by CMA and partially owned by MSC. At least they used to be. I'm not exactly 100% sure how the current shareholder setting is, but Traxens, and that is not blockchain based. That is really a centralized system and not blockchain based. But that has been adopted by the Digital Container Shipping Association as their IoT standard for container tracking.
I think we have no more questions here. I want to thank you again, Alyosha, for the very interesting talk and the valuable experience that you shared with us. Next, we have a technical session chaired by Ali Dori. Thank you, Alyosha. Yeah.
Thank you.
Okay, thanks, Volkan. We'll next have our second technical session. My name is Ali Duri. I'm a research fellow at Queensland University of Technology. I'll be chairing this session. We'll start with the first paper, which is the convergence of blockchain and machine learning for decentralized trust management in IoT ecosystem, presented by Tarindu Ranathanga from Master Technological University. Thanks, Tarindu, for joining us. I'll hand over to you for presenting the paper. Thanks. So you're muted.
Okay, yeah. So hope you can hear me.
Yeah.
Thanks. Okay, I'll share my screen now. Yeah, so, okay. So my name is Tarindu Ranathunga, and I'm a PhD student at Master Technological University in Ireland. And today I'll be presenting our paper, The Convergence of Blockchain and Machine Learning for Decentralized Trust Management in these IoT ecosystems. So if you look at what these IoT ecosystems are these interconnected systems that consist of different network services and consist of different network participants, for example, organizations, consumers, governments, and these businesses who are like interested in taking part in this ecosystem. And we have this network component such as nodes or devices, for example, these sensors, actuators, and smartphones, and the communication technologies that is associated with that. Also, we have, most importantly, we have this data that is generated from these devices. So these IoT ecosystems can bring flexibility to interconnect and operate between these ingredients, but it also comes with the risk associated to the trust of this ecosystem. So building trust in this trustless environment is quite challenging because of its diversity, interoperability, and the scale of the networks. So in this work, we are trying to solve the problem of trust management in these IoT nodes. And we consider a node is untrusted or not trusted if it's a malicious or a malfunctioning node where the device is not functioning as expected. So identifying these untrusted nodes are quite important because it can cause long-term impact on the environment, or it can cause economical losses, or even it can be a risk to this human life. So in the literature, there are a few models like based on trust reputation to distinguish this malicious node from a models and centralized. So in this peer-to-peer model, trust is built based on the observation from a node and also from this recommendation from the other nodes. The problem with this type of approach is that these nodes can be resource constrained and they cannot run these complex trust computation algorithms inside these nodes. So this type of problems can be overcome by allowing a central party like a cloud server to perform this trust computation, but it comes with problems such as single point of failure, scalability issues, privacy violations, and so on. So apart from that, these networks are dynamic and they change they evolve over time, and a trust model should be able to reflect or adapt to these dynamic conditions. And also these IoT networks are multi-layer in nature. So we should build this trust across these layers. And in building this, we will have to trust one layer in performing the trust computation of the other layers. So the blockchain is a potential technology to overcome some of these challenges. And recently we have seen this blockchain-based novel trust reputation model as well in the literature as well. So as you might already know, like these are the main features that a blockchain can offer into a system. And this is how these features can be used to solve the problems in trust management regarding to IoT ecosystem. So the blockchain is decentralized in nature, which means that there are no intermediaries. So this blockchain can be a layer to perform the trust computation. We do not need to trust that layer explicitly. And also these blockchains are immutable, so we can record this trust footprint of the devices in a tamper-proof manner. So at the same time, it will provide this necessary traceability over the evidences that we use to perform this trust assessment. And using the smart contracts, we can automate the trust computation process, and it will provide the necessary compliance. So blockchain, when converges of technologies like machine learning, we can perform more intelligent trust computations. So the benefits of this convergence of two technologies is two-way. So this machine learning will help these smart contracts to take more intelligent decisions on the chain. On the other hand, this blockchain can be used to ensure that these machine learning models and the data that we use in the training process are trusted. So in the context of trust management, it will help us to create more intelligent models which can capture these dynamic and domain-specific features by exploring the data space. And the blockchain can be used to automate the model retraining process when it is needed. So here in this paper, we propose a blockchain-based cross-layer intelligent trust model using machine learning. There we propose a decentralized trusted off-chain workflow for machine learning model management, and also ran a smart contract-based reputation model based on these machine learning-based evidences. We also provide an implementation of our proposed model and also an initial evaluation of it. So our model, our trust model consists of mainly two workflows to ensure trust. So first one is the off-chain cross-layer machine learning-based evidence gathering, and this is this off-chain component, and also an on-chain trust reputation model to quantify these IoT devices, quantify the trust of these IoT devices. So if you go into the model, if you go into the component, so we have this. First, we have this off-chain components, so such as machine learning models, where they are deployed across different layers in the system, and these machine learning models are trained to detect untrusted behaviors, such as malicious or like anomalies in data. And we have these trusted workers who will help these machine learning models in their detection process by doing the necessary pre-processing, and also by this model execution. And also there are like blockchain client who will report these prediction from these machine learning models onto the chain. And all these off-chain components are executed inside these trusted execution environments to provide the required integrity and the security. And like most importantly, we have these smart contracts. Mainly, in our model, we have three main smart contracts. So first one is the asset identity contract, which will manage the identities of these IoT nodes and all the trusted workers which are deployed in these layers. And we have this model identity contract, which will keep track of these machine learning models and their performance parameters. And most importantly, we have a reputation contract where our trust reputation algorithm resides, where we do this trust quantifying process. So we have proposed a trusted workflow to ensure the trust during this off-chain component execution, as well as during the trust reputation calculation. And here we follow the Enterprise Ethereum Alliance off-chain trusted workflow specification in deciding this workflow. So initially, we provide a workflow to provision these machine learning models and the trusted workers. So once we have a trained model, we register that on the chain prior to the deployment. So which will create an identity on the chain along with the model performance parameters, such as these recall, precision, and accuracy levels of the model. Also, we provide the required trusted workers who will help in this model execution process, and also a test data set to verify the model performance. So this will allow blockchain to discover these trusted workers and they test the performance of the model at any point of a time. So they can get a confirmation about these accuracies of the model. So which will also be recorded on the chain. So that confirmation also would be traceable on the chain. So similarly, during the network operation, all the IoT nodes will have an identity on the chain. They need to be registered on the chain as well. So these the models that are deployed in different layers will do the required pre-processing of these network data or the data from these IoT devices, and then they will report their prediction to the chain. So the model deployed after they predict their prediction to the chain, the blockchain will be able to verify these models, so whether they are trusted. So if the conditions if all the conditions are met, they can then start performing these trust reputation calculations on the chain. So this is how we quantify, this is how we do the trust reputation calculation. So in our model, we will have these multiple machine learning models deployed across these the IoT layers. The output of these machine learning models will be either positive or negative based on these on the observational windows. So for each observational window, we quantify the level of trust, and like it will be either negative or positive, which will be a value between -1 and +1. And this value is weighted with the model performance, So this will allow us to give a higher weight to this best performing model when the model score or the reputation is calculated. So once the reputation from a latest window is calculated, then we aggregate with that the previous reputation that we calculate to kind of calculate the overall reputation. And here we use an aging parameter to tune the importance given to these observational windows. And if you go to the implementation of the model, we kind of have two aspects. So first one is this the machine learning model training. So at this stage, we have only considered these network level attacks, especially the flooding attack, version number attack, and the decreased rank attack, which can be commonly seen in these wireless sensor networks. And we have done CUJA simulation to generate a data set to train few models to detect the IoT nodes that are performing these kind of attacks. So the model training would be like, it would be similar to a normal machine learning model training process. So where we have this feature extraction, labeling, normalization. And then, so at the end of a training, we will be having a trained model to detect each kind of attack. And also there are the model metadata, which means the model performance parameters such as these precisions and recalls. So for example, in this table, I have summarized the model performing parameters of our initial machine learning training for each type of attacks. And if you go to the blockchain level implementation, for the blockchain layer, we have considered this Hyperledger Fabric as in our implementation. So because it is a permission kind of an blockchain platform where only pre-approved members can join into the network, and it provides a very modular architecture which is helping a lot in our deployment process. And also it has smart contracts implementation which can be done in like Go language and Java and Node.js as well. And we have like the other components would be these off-chain components, such as these trusted workers, where we have implemented them as these Docker containers. And at the moment, we are working on executing or running them on this trusted execution environment using these frameworks like SCORN framework. So we have conducted a few initial experiments to evaluate our model performance, as well as this blockchain level implementation as well. So we were mainly interested in finding the required hardware configuration to support our trust propagation requirements, as well as we were interested in evaluating the behavior of our trust model as well. So we have kind of have deployed a blockchain network distributed on a cloud servers. So it consists of 3 nodes or 3 organizational units, and each organizational unit was deployed on a separate VM instance, which consists of 8 virtual CPUs and 30 gigs of RAM. And also, we have evaluated this reputation model through a CUJA simulation. Here we have computed the reputation of a random, malicious, and a benign node in the network, and then we have compared that with the ground truth. So with respect to our setup, we could achieve up to 190 transactions per second with an average latency of 0.5 seconds, which means that it can handle up to 190 transactions 190 trust update transactions with an average latency of 0.5 seconds under the hardware configurations that we have given. So it kind of gives us a baseline understanding about what would be the scalability of our system. So if you go to our second experiment, so we kind of see a reputation of this random benign node as a convergent behavior towards the ground truth. And in these malicious scenarios, we sometimes see an abnormal spikes on the reputation, and this is caused by these false negative detection of our trained models. So as future work, so we are trying to control this trust growth to be prone to these false negatives and false positives, and we are kind of exploring trust growth functions like Gumpert functions, as well as we are considering training few models that can detect anomalies at the cloud layer as well, so which can be integrated in our model as well. So then we will looking forward to, we will look for the possibility of doing trust aggregation between these layers, and also we will be finding these triggering conditions for the model retraining. So we will be finding that at which condition that this model performance will go down, and will be automating the model retraining process through the smart contracts. Yeah, so that's the end of my presentation. Thank you for listening.
Yep, thanks. Thanks for the great talk. It was a very interesting area. Indeed, trust and trust in the blockchain is indeed a great topic and very timely. I can see no comment or no questions on the Slack. Maybe I just ask one. In terms of your trust calculation with the machine learning algorithm you had, my assumption or my understanding is that you're running the algorithm on the edge network, and then do you add any extra field to the blockchain transactions that will count the trust to that data that has been exchanged, or how would you manage the actual trust values?
You mean after trust computation or during? Yeah. Okay, yeah. So basically, this is kind of an trust model that will fit in a framework that will kind of manage the trust of a life cycle of an IoT devices. So in that framework, we have these identity management components and access control and so on. So the result from this model would be used to decommission these IoT devices if they are not trusted. If these trust values pass a certain threshold, they would be automatically decommissioned from the device or from the network.
Okay, great. Thanks. Yeah, I see no question from the chat box. So thanks for presentation and joining us today. Thanks.
Okay. Thanks, Ali. Thanks, everyone.
Okay, so our second paper, technical paper, would be blockchain-based decentralized service provisioning in local 6G mobile networks, presented by Taras Maximiuk from Lviv Polytechnic National University in Ukraine. So I'll hand over to you, Taras. Looking forward to your talk.
Hello, everyone. Okay, I will share my screen in a moment. Okay, I believe it should be visible now, and I can proceed to my presentation.
Yes, yeah.
So I believe it is visible. So the title of my presentation is blockchain-based decentralized service provisioning in local 6G mobile networks. So the paper is co-authored by my co-authors from Technical University of Košice and also from University College Dublin. But in particular, Marko Sanka also works in University of Oulu, so that this research is involved to the 6G flagship project. So I will start from my first initial slide. And as you may know, I think it is not a secret what is 5G. Everyone is speaking about it now. And currently we have all this convergence of different types of connectivity, different type of services. And 5G somehow augments a lot of different applications, which I explained on the slide. But the question arises from that complexity, as we can see, is it reasonable to use only one mobile operator for all these types of services? It is clearly seen that all the services has different requirements, and perhaps we can think about changing paradigm a bit and move to the concept of local mobile network operators like that. So now we can assume that different type of services can be provided by different operators. But now we need to manage all these things together with some general framework, which can enable spectrum sharing, infrastructure sharing, and bring all of this together. So one of the reasons for that, let me explain from the slide provided by Digital Catapult. You can find it by this link, that most applications have different requirements. As we can see here, for example, we have Industry 4.0, we have smart cities, we have media, augmented virtual reality, and so on. And we cannot directly compare requirements of one service to another one. And maybe it would be reasonable if we have different operators who are specially focused to provide different specific part of services. And in that case, that can allow us to simplify hardware and choose only necessary configuration, which will cover our target use case. So what is a main proposal of our work here? We propose to develop this kind of multi-plane architecture, which combines blockchain technology and artificial intelligence to manage the whole network infrastructure and, most important, spectrum resources, which are very scarce, and we need to manage them as tight as possible. So in general, we define that we have user plane, which is completely separated from network infrastructure, and then we have different mobile network operators, which can be either national, regional, private, or vertical. And to manage all these operators, we need the trustful infrastructure, which can be provided by blockchain technology. So we expect that we will use smart contract agreements between different operators, and also between operators and end users, to provide different types of services and also exchange spectrum and infrastructure. And in general, it is all should be managed by a higher level of AI framework, which can track different patterns like traffic, resource management, mobility management, quality control, and so on. And it should be connected according to the cycle, which is shown by these arrows from down to top, and then now from top to bottom. So to make it fast, I will proceed to explanation what is one of key points which we consider in this research. First of all, we need to rethink the quality of experience definition for 6G, because it seems like we already missed it in 5G, but hopefully with new standards, we can bring it all together. So the general point is that all these quality parameters are very sensitive to different aspects of user context. For example, It depends from the environment, time, location, surroundings, type of activity of end user, as well as his personality. So social demographic status, financial capabilities, psychology and mentality. And also, of course, measurable QoS parameters, which we consider all the time, such as throughput, latency, packet loss, etc. And based on all these parameters, we can define a utility of end user, which can be represented by the following equation, where we need to match service quality, service price, and trade-off between them. And if we're going to explain it by partial parameters, we can define throughput, latency, packet loss, user priority, and service price in one tuple, and then we can define partial normalized user utilities, which can be adjusted by end user by modifying this trade-off parameter for each partial service parameter. It allows each user to define his own custom service quality definition, and that will affect significantly the choice of network connection and also the happiness of the user in terms of services. And then we can represent all these things together with following metrics of services, users, and MNOs, which is sparse, and then all these data flows can be represented separately according to different options of connectivity for end user and type of services. So then these data flows we already bring it there, and now we define our blockchain empowered multi-operator 6G ecosystem. The main feature of this ecosystem is that it is split into different market players, such as spectrum owners, infrastructure owners, spectrum regulator, and of course users. So by using blockchain as intermediary tool to connect all these parties together, we can enable the partial resource allocation of each operator, and also we can enable flexible connectivity of end users and to different mobile network operators. So in general, operators starting from now will need to combine or somehow acquire network infrastructure and then spectrum, and then by having spectrum infrastructure, each operator can provide service to end users. It is all dynamic or quasi-dynamic, which means that we are moving out from the concept of big national operators, which handle all things together. And once you bought a SIM card or connected to some data plan, you became a sole user of that operator. And by that representation, we can define different partial data flows, which I explained by this set of equations, where we can define separately for each user, for each type of service, for each operator, and for each base station, which means that we can flexibly allocate all necessary resources, depends on target requirements. Now let's proceed to another important aspect, which we define in that model, which is based on spectrum and infrastructure tokenization. The key idea is that we use non-fungible tokens, which can represent a specific spectrum band or specific infrastructure element, and then we digitize those assets to non-fungible tokens, which can be traded by blockchain. I believe that most of the audience here know what is non-fungible token. Briefly, I can explain that this is token which is unique. It means that once you bought a token of base station, you cannot find another token of that base station. So only one operator can own the token, and as long as operator holds the token of base station, he is considered as owner of that base station. The same applies for any spectrum band as well, depends on spectrum distribution and separation strategy of the country. And by combination of those two tokens, we can update the scheduler, which is shown in that right bottom picture, where we have infrastructure resource token and also partially two different licensed resource token, which means that only operator who has this hash value of the token can connect to the control system of base station and then can make corresponding modifications. It means that we can transfer the rights of use for different infrastructure elements only by transferring those tokens via blockchain. So the same for infrastructure, as long as you bought, the same for spectrum. As long as you have in your possession any token of specific radio resource, you can use this radio resource in your scheduler and provide service to your customers. So the corresponding algorithms for spectrum and infrastructure sharing are presented by those two pictures. And the key idea is that we have a smart contract which can manage these procedures of spectrum leasing between operators. As well, it can manage infrastructure leasing between operators. But again, let me remind that all these parameters are done by transferring corresponding tokens in the blockchain. So to save time, let's proceed to our next part of the concept, which is in the user identity. We need to think what kind of user identity we can have in the future, because we had, starting from SIM cards, then we had smaller SIM cards, and now we have already embedded or electronic SIM cards, which are installed directly in the smartphone or some wearable device. But now we can think that we can move out from that paradigm of SIM cards, which are offered by mobile network operators, and develop one single blockchain user ID, which can be shared among all mobile network operators in any country of the world, for example. It means that you have unique ID in the world, and then by using this ID, you can connect to any mobile network operator in the world. It simplifies a lot of things. You don't need to change SIM cards anymore. You can just make it in dynamic way, such as connect your mobile phone to the open and available networks. The question, are we ready for the blockchain-based user authentication? Because it brings a lot of additional problems, such as overhead of transactions, and also it raises a lot of questions. What kind of blockchain we can use? What type of consensus algorithm should be applied? So it is open question. Maybe 2025, maybe 2030, who knows? But I believe this is maybe a question to the audience, because here we have a lot of blockchain experts, and we already had keynote this morning where such kind of ideas have been mentioned by a presentation from IOTA. So what is the use of that ID in current model is that we can bring the capability of adaptive service selection by end users in multi-operator 6G environment, which means that each user with specific requirements can make a request to the blockchain for getting the corresponding service. And then all mobile network operators who are available in the target area can offer normalized service quality parameters along with service price, which then again moves us back to the utility evaluation, so that each user, and we remember that each user has specific trade-off between price and quality. It means that he has a unique way of calculating his own utility function. And then we define that user can find his own integrated user utility, and by using that criteria, we can select the higher utility among all mobile network operators. It means that among 10 offers, our user will select the best possible option for his own connectivity. It will depend on many factors. It will depend on the type of service. It will depend on the price. It will depend on the time of service provision. Or is it some instantaneous short-time connection, or is it long-term connectivity which should be managed through different places during the few hours, for example? It brings a lot of additional complexity, which will be solved maybe in the future, but the general idea is to have this possibility and option to define flexible connectivity for each user in the current framework. And we had some simulation results, which have been simplified, of course, but we have compared different cases of spectrum sharing between operators, as well as user selection among all operators. And we see that by enabling dynamic trading of spectrum and infrastructure between operators, we can offer higher average throughput for the same price for end users, which is natural because, as we mentioned in the previous slide, users tend to choose the highest possible utility. It means that in general, users are more skeptical and more critical for the evaluation. And that forces operators to decrease price and increase utility. But also, we have found interesting results that the profit, which we expected to be worse in the case of dynamic trading, because if a user can select the cheapest option, it means that operators somehow lose redundant profit. But it turns out that by enabling flexible spectrum trading between operators, we can decrease the number of idle spectrum bands, and actually the spectrum waste goes down and utilization goes to almost 100%, which means that in general the efficiency of spectrum utilization is higher, and operators are able to provide much more services to a higher number of users. So in general, in terms of profit, it is also beneficial. The key limitation of this experiment is actually that we were not able to compute directly what kind of overhead will be brought by blockchain to the time and, for example, transaction time of between user switching from one operator to another operator. And in general, we have just defined theoretical comparison of different consensus algorithms, different blockchains. And it is a bit obsolete. I believe we should put also Ethereum 2.0 here, maybe also Polkadot, and a few other new architectures. But it turns out that, of course, proof of work will not work at all in this concept because of high overhead and high energy consumption. Perhaps we can think about some options related to proof of stake, maybe with development of Ethereum 2.0 and Polkadot, it will bring better results in the future. As well, of course, we have delegated proof of stake, which has proven to be fast enough. We have proof of formulation and also a few other options, perhaps also XRP Ledger as well, because currently they are moving towards NFTs, according to last news. So in general, additional studies are needed to find the most suitable blockchain implementation for that proposed concept. But we can see that we already have a lot of topics which somehow opened by using the integration of blockchain with 6G and even 5G mobile networks. For example, spectrum sharing, infrastructure sharing, and network slicing, which I skipped today because of lack of time. Service level agreements, as we already mentioned, also authentication, authorization, accounting. Important functionality is a seamless international roaming, which can be brought by blockchain because the current concept doesn't make it different to connect either to local operator or to some international operator. So you can just directly get on a plane, fly to US, and once you turn your phone on, you will be connected to Verizon or other operators in US just by using your blockchain ID, which is recognized internationally. Also, we already mentioned local area mobile networks, which is important because we will bring a lot of new mobile network operators. Intelligent networking, because blockchain allows us to track a lot of transactions and store all parameters in immutable way, which allows them to use all the available data for testing and solving critical problems. Another important thing that our regulators can be empowered by blockchain, because now all transactions are transparent, and FCC or other regulator in any country can just check latest state of distributed ledger and find out all the activity in the network. And also integration of blockchain and artificial intelligence by any means. And this list is not complete, so we can add anything there. Additional options will be available, I believe. But I believe it is enough for now, and this is all from my side. Thank you for your attention. And if you have some questions available, I would be glad to answer.
Great, thanks for the great presentation. There is a question in Slack, I'll just read. Is the blockchain ID similar to MetaMask identification that is currently used by many websites? In other words, is the goal of blockchain ID to use signature to identify objects using 6G? If yes, is the 6G SIM card handling the blockchain ID signature?
Okay, thanks a lot for the question. I'm not sure that I understood all questions, but in general, I believe that blockchain ID will be similar to MetaMask ID. It is not yet known how it will be implemented because it's just a vision. There are not any standards for 6G available yet, but we have assumption that if we bring this concept of local mobile network operators, and if we are going to use blockchain as an intermediary solution to provide interconnection and cooperation among operators, it can be very quickly supported by vendors who are developing mobile phones. And I believe that Apple, Samsung, Huawei, and other manufacturers will bring a new target device which will handle blockchain ID in a nice way. We already had this experience once 5G became a reality. All mobile manufacturers started to install chips and CPUs which have support of 5G radio access technology. So once we say that blockchain will be standard solution and blockchain ID will be needed for connectivity, all mobile phones will be equipped with that ID very quickly. And actually, because we already have unique IDs of each mobile phone, which is IMEI number, that IMEI number can even be used as some input parameter for that blockchain ID. For example, blockchain ID can be developed as a hash function of that IMEI number. And once you have unique IMEI number, you will have unique IMEI ID. And then it is up to regulators how they will assign this ID to people. Do we need to somehow bind it to our passport data or not? It depends on the country and internal laws.
Okay, great. Thanks. And I think that's all the questions we had. And thanks for the great presentation.
Thanks for your invitation. It was very nice to participate in your conference.
Yeah, thanks.
Let's keep in touch. Thank you. Bye.
Bye. Okay, so we have our last presentation for this session. The paper title to be Experimental Scalability Study of Consortium Blockchains with BFT Consensus for IoT Automotive Use Cases, presented by Sarel Naives Samuel, University Côte d'Azur. Hopefully I'm pronouncing correctly. Okay, so handing over to you. So the presentation.
Yes, thank you. Wait, I'm gonna first share the screen. Okay. Does it work correctly? Okay.
Yes.
Yes. Okay.
Yeah.
So hi Ali. Actually, it's good to see you, and thank you for allowing me to speak here at this workshop. So I'm Luc Geritz, and I've done this work on experimental scalability study of consortium blockchains with BFT consensus for IoT automotive use case. And I've done this work with Cyril Samuel in partnership with Renault Software Labs. So first, we'll talk about the context. So the context, the use case. We have Renault's cars represented here with the two pictures, that are connected to blockchains that are deployed in several clouds. And each time an accident occurs, we will have an IoT inside of the car that will send a transaction to the cloud, to one of the clouds. So we focus only on the Renault cloud, where the IoT sends a data hash to Renault cloud each time an accident occurs. We actually have seen in previous work that we require around 25 finalized transactions per second to be handled in the blockchain, in the private blockchain in the Renault cloud. So the goal here is to combine an automotive use case with a performance study, and that leads us to explore the adequacy of consortium BFT blockchains. So because BFT blockchains is used in private networks, or mainly in private networks, we want to study those consortium BFT blockchains. So here, first we need to evaluate BFT consensus performances. We are going to study actually 4 consensuses with the practical Byzantine fault-tolerant consensus that is made by Hyperledger Saltus. And then we have 3 other consensus that is part of the proof of authority family consensus that is made by Ethereum with the CLIC consensus, the IBFT for Istanbul Byzantine fault-tolerant consensus, and the QBFT Quorum Byzantine fault-tolerant consensus. So first, the first step is to create a smart contract. In Hyperledger Saltus, we have done a transaction processor. It's analogous to a smart contract. And then we have done a Solidity smart contract in Ethereum. So after creating and deploying those smart contracts, those blockchains, we're going to do some benchmarks. So on each consortium network configuration, we will do a benchmark. And this will help us to analyze the scalability and performance of each consensus. And with those results, we will compile and normalize them. And this will lead us to explore which consensus is the most appropriate for the automotive use case that we have talked about just before. So one word about how do we measure the performances? We actually measure the transaction confirmation per second. So in other terms, the finality. We call this the finalized transaction per second, so FTPS. We're going to see this word a lot. And we also look at the influence of the number of nodes and the scalability, so the number of nodes versus the finalized transaction per second. So we have first implemented all of this. How do we have implemented all of this? We have in the cloud, so we have a task group cloud. It's a cloud service provider, and it has Kubernetes installed, and we have the blockchain that is going to be deployed in this Kubernetes cluster with multiple pods, and also some monitoring services. So for example, Grafana, InfluxDB for the database, and we're going to retrieve some metrics and store that into InfluxDB. In the case of Ethereum, we have this configuration like this. In the case of Hyperledger Celsius, we have almost the same configuration, the cloud configuration. We have only different pods with different software inside of it. Also, we notice here that we have some IoTs that is actually simulated to send the transaction, the car accident transactions. And in those vehicles, we actually have an IoT that should that have to build the transaction. And in this transaction, it will execute the smart contract, of course, and it will also contain a vehicle data hash. So the data that could be sent is actually odometer data, speed data. It could be also radar information, and so on. So, and this will be sent here to the blockchain network. Okay, so the results. First, we have PBFT, practical Byzantine fault tolerance with Hyperledger Celsius. Here on this graph, we have represented the finalized output transaction per second, depending on the input transaction per second. And in each curve, we will have a different configuration, different node configuration. So we have, for example, 4 nodes here in pink and 24 nodes in blue. And we see immediately with this graph that increasing the number of nodes actually leads to a lower finalized transaction per second. So in this case, with PBFT, we'll have maximum FTPS of 25 that we see here. And actually, we see also that there are a lot of transaction rejections and pending congestion for an input transaction per second that is higher than 50. That's why we actually stop at 50 here. That is because of this. Also, we see that there is a bottleneck that is due to the software limitation. Some of the parts in the latest Hyperledger Celsius core software is still in Python, and they're still changing it to Rust. They're actively changing it to Rust. So maybe it's going to be better in the future, but for the moment, there's still a huge limitation in the software. And there's also a very high consensus communication complexity. In PBFT, the complexity is in order of n cubed. So that's why when increasing the number of nodes, we will have a lot of more communication between the nodes. So that is one of the reasons also that we get this bottleneck in the finalized output transaction per second here. So next we have the result for the click consensus from Ethereum. Actually, the get implementation, maybe you already know that, I don't know. So with the get implementation, with the click consensus, you can have a minimum number of validator of 3, but we choose to do 5 because we want to compare it with IBFT and QBFT. That's why we start with 5 nodes here. And here again, we increase the number of nodes, and we see with an input transaction per second that is actually much higher than the one before with QBFT. We see that the maximum output FTPS, in this case for click, is 1,500. So that's what we see here. And next, we see also in this region here that the FTPS is limited for an input transaction per second that is higher than 2,000. 2,000 in the case with 5 nodes, but in the case of, for example, 10 nodes, we already have the limitation starting with an input transaction per second of 1,500. So here we have also a bottleneck that is due to the high hash calculation in the EVM, in this case, and also to high number of forks in the chain. Okay, so yeah, this is just to say that PBFT, FTPS of PBFT is lower than click, of course. But in the case of IBFT, we have here something different a little bit, where the maximum FTPS is 450 transactions per second that we see here on the top here. And then again, increasing the number of nodes, decrease the finalized transaction per second in output. But here the limitation is around 500 with an input transaction per second of 500 transactions per second. So when we input more transaction per second than 500, then we won't get more finalized transaction per second. We actually get less finalized transaction per second. So it actually decreased the performances. Here, the bottleneck is due to the high hash calculation, but also, of course, of the high consensus communication complexity. In this case, it's a complexity of order of n square. And yes, and here we see again that PBFT less than IBFT, and click is still on the top. So here we get something similar, but we have a little bit better finalized transaction per second, and that is of 465 transactions per second. Again, increasing the number of nodes, decrease the finalized transaction per second. And again, here we see that having an input transaction per second higher than 500 will actually decrease the finalized output transaction per second. And in this case, we have a limitation of the high consensus communication complexity, also of order of 2 square, n squared. But the interesting part is here, where if we normalize all the output transaction per second over the maximum finalized transaction per second of each consensus. So for example, in the case of click, we will use 1,500 as reference for the normalization. So at 1, we will get 1,500 transactions per second. In the case of IBFT, we will have 450, etc. And in this case, here we see that in this graph, we plot the finalized output TPS, the normalized finalized output TPS, depending on the number of nodes. So we see here the general tendency that we saw before, that increasing the number of nodes have a decrease of the FTPS. And we see that in the overall BFT FTPS, best performances, it is actually obtained with a minimal number of nodes. And we get actually a decrease immediately after if we use more than 4 nodes. But in some cases, it will take a bit longer. So for example, in the case of IBFT in green here and PBFT, we will have a decrease that is a very drastic decrease in the finalized transaction per second. But in the case of Click, it will be very linear, the decrease, and in the case of QBFT, it's quite interesting because the decrease only happens after around 10 or 12 nodes here. So, and even can go up to 15 if we accept a little bit of decrease in finalized TPS. So also here we see in this conclusion, the generalized graph, normalized graph, that Click actually has, of course, the highest output FTPS of all consensuses that we study, but it lacks finalities, it has high forks. In the case of QBFT, we will have actually an output FTPS that declines only after around 10, 12, 15 nodes here. And we see that in general, that there is already a well-known BFT algorithm issue, that is the communication overhead that prevents the Byzantine faults. So we always have this issue with those BFT algorithms. In the case of PBFT and IBFT, we will actually have a low transaction per second. PBFT is the lowest of all of them. In conclusion, in this work we have done, we have implemented the use case, an automotive use case, where we have smart contracts, IoT sending transactions. We also have compared multiple BFT consensuses. And also in the following this table, we actually see that QBFT is one of the most appropriate for the automotive use case, because we consider the maximum finalized TPS, the finality, and the scalability. So in the case, for example, of Click, we will get a very high TPS, not a good finality, and okay-ish scalability. In the case of IBT, we won't have scalability. We will also good TPS. And in the case of QBFT, we'll have a little bit of both of them because IBFT has finality. So we'll have a mix of Click and IBFT. And PBFT, we won't even mention it because it has actually a very low TPS and it actually doesn't really fit for the IoT automotive use case that we have talked about. So we have here some of the references, acknowledgements, and maybe somebody has some questions. And thank you for listening to me.
Good. Thanks for the interesting talk. First, I need to correct myself. Sorry, I thought that Cyril is going to present. Look, so I
it's not a problem.
used the wrong person. Yeah, that's fine. Okay, so let's see if we have any question from the audience. Okay, so we don't have any question on Slack. So I guess then, yeah. Thank you for the great presentation and for the talk. Yeah.
Thank you. Thank you for having me here. Maybe see you soon.
Yeah. Okay. Thanks everyone for joining this session. We'll have a 15 minutes break, and then we'll start with the next session.
Hi, Raghu, can you hear me?
Hey, Gauri. Yeah, I can hear you.
How are you?
I'm good. Thank you.
Right.
Are you in Australia?
Yes, I am. Yeah.
What time is it there? Very late in the morning. Very late at night, correct?
Yeah, it's 1:20 a.m. now. Yeah, it's a long night for us.
I know. That's fine. How are you settled down? Are you settled down
Yeah,
now?
all good here. Yeah, settled down.
That's great.
No, we can wait for another few minutes.
Yeah. No problem.
Yeah.
No problem.
Hi Raghu. I think it would be good if you share your screen and
Yeah, sure.
make sure it's working.
Sure. Let me get going here. Can you see my screen?
Yeah, all good.
Okay, cool. So let me start the slideshow.
Okay,
all right.
Great. Yeah, let's wait for a couple of more minutes and then
Sure.
start.
No problem. Great.
All right, I think we can start. Okay, welcome back. Yeah, welcome back, folks. And we are into the final session for the day. And it's my pleasure to introduce Raghu Bala. And Raghu Bala is CEO of NetObjects based in California, USA. And he's an experienced technology entrepreneur and is an alumnus of Yahoo InfoSpace, PwC, and he has had 3 successful startup exits as well. And he has an MBA in finance from Wharton School and an MS in computer science from Rensselaer Polytechnic Institute. And he also has a BA and BS in math and computer science from the State University of New York at Buffalo. And he is ex-Columbia University adjunct lecturer, currently tutoring MIT courses in artificial intelligence and blockchain on the Get Smarter platform. And he is a published author of books on technical topics and is also a frequent contributor online. And he is also a co-author in an upcoming book titled Handbook on Blockchain for Springer Publications. And he has spoken at several conferences worldwide, including Asia Financial Forum in Hong Kong, Blockchain Malaysia, IoT India Congress, Google I/O, and several more. And he's also an elected member of AAM, the Global Industry Association that connects, standardizes, and advances automatic identification technologies. And his current areas of focus include product development, engineering, and strategy in the businesses, or services and software offerings related to decentralized computing, distributed ledgers, IoT, artificial intelligence, and the metaverse. And his domain knowledge is vast, including automotive, retail, supply chain and logistics, healthcare, insurance, mobile, and wireless. So Raghu is going to, talk about asset tokenization here. So I'll hand over the floor to Raghu now to start his presentation.
Thank you, Gauri. I appreciate it. Hi, everyone. I'm going to be speaking about asset tokenization. And basically, this is the agenda for today. We're going to talk about what are assets, how they are owned, how they are valued, and the various factors that come into valuation. And what we are seeing in the industry right now is due to the advent of blockchain, a lot of assets are being tokenized. And obviously, tokenization means the underlying premise of using blockchain. And we're going to look quickly at some blockchain architectures in case someone in the audience is not very familiar with some of the architectures and so on. And then we're going to talk about the different types of tokens you can use to tokenize assets, fungible tokens, non-fungible tokens, things of that nature, and then some use cases and case studies in various industries. So with that, basically we are seeing a kind of a change in the landscape. Obviously we've all lived through Web 1.0 and then which was advent of e-commerce and various email and other things, basic infrastructure. Then Web 2.0 was more social media and mobile and other things. Now we are going towards Web 3.0 is what we can say is more AI driven, decentralized computing architectures and edge computing. And in this era of what we are moving towards is a distribution era, subscription era, and ownership era. And when we talk about ownership, we're talking about assets, and assets are not kind of a homogeneous thing. It's heterogeneous. There are many types of assets. I'm going to cover basically 4 types of assets: digital assets, physical assets, what we call dynamic assets, and then financial assets. I'll cover that in a second. Now, in terms of if you are looking at just at a high level, a lot of these Web 2.0 companies that we're all familiar with, we use their tools every day. Now we are seeing the sort of like growth and revolution actually in some new companies in the Web 3.0 era. So, for example, if you have used Dropbox, now you're using a storage or a SIA, which are our Filecoin, IPFS, for some of you who might be familiar with it, interplanetary file system. So these are blockchain-based storage mechanisms, which are like the parallel of, let's say, a Dropbox or S3 in the current world. And then similarly, there are parallels one can draw in various areas like DNS, in the storage of data, in music sharing and things like that as well. Now, let's talk about assets, which is what we're going to cover today. So assets are, are things that produce value. And I'm not going to read through the whole slide here. I'm just going to give you the idea of the gist of it. And in the case of assets, I was at a media company some time ago. I was the CTO of a media company. And in this media company, we were, producing content. So content is a funny kind of asset, actually, because asset is something that is that can be converted to produce revenue, actually. So in this media company, we were doing car reviews and things like that. So let's say a BMW 3 Series car review. Now that kind of content is very evergreen because that BMW 3 Series for 2021 model, that a lot of readers could read that content over and over again, and we can monetize it through ads around the page and things like that. So that's booked as an asset, not as an expense when you create that content. But then let's say CNN, yesterday's news, nobody's going to read. They change the website, 2-3 times a day because the news has changed. And yesterday's news is yesterday's news. Nobody's going to look it up. So that cannot be classified as a content because asset, because that's it loses its value immediately. So that's probably an expense in their books. So when we talk about assets, we're going to look at assets from a kind of a financial accounting standpoint. So all of us are familiar with asset ownership, and typically, the big assets that everyone owns in their lifetime tends to be a car and a house. Those are the big ticket items you tend to own. And the way asset ownership is classified is that you have a deed or some sort of title to that particular asset. Or let's say you have a deed to your home. Or if you own some stocks, there might be a stock certificate. So that says that you own this particular asset. Now, asset ownership can be whole or fractional. This is important because when we start to tokenize assets, one of the benefits of tokenization is the ability to kind of take an asset and kind of chop it up and split it up and have fractionalization. And then assets are not, the asset ownership, while homes and cars, there is a record, public record that says that you own, John Doe owns this car or Jane Doe owns that house. It's not very pervasive when it comes to other types of assets, like let's say jewelry. It's got value. You might have a necklace worth $10,000 or a Rolex watch worth $20,000, but there's no record to say, what, Gauri owns this Rolex. There's no record to say that in general. Usually what happens is you fill out a registration form and you send it to the company that, manufacturer, but that's rarely done also. So it's very sketchy in terms of how the ownership history is maintained, and also applies to things like art. You can have a piece of art, very expensive art, but there's nothing to prove that you own it. And so that has got a carry-on effect when it comes to insuring things and so on. This is a topic I'll touch on later on in the deck when we talk about diamonds, one of our use cases. So now let's talk about valuation of assets. So in some cases, assets are easy to value because there's a global market standard. Like, for example, if you look at gold or silver or crude oil, those are assets. But then you can go and look it up in the exchange, like the COMEX or the NYMEX and so on. You can find out the price, the prevailing price of gold. In fact, you even can find the future price of gold, the futures traded. But then, so that's easy to determine, right? Second type of thing is if you put gas in your car, that gas price will be more localized, because usually in the case of gas, there's local taxes. So in America, for example, gas in Texas tends to be fairly inexpensive because it is oil mining happens in Texas, is one of the hubs for oil. And so the prices tend to be lower, and I don't think they put as much tax on it. For example, I live in California, so gas prices are very high because California is, is one of the states which is very environmentally friendly. So they don't like pollution. So in order to reduce pollution, they tax a lot. So the same gas, a gallon of gas, which might cost $2.50 in Texas, will cost $4 in California. So that's a kind of a difference in price, and that's the local market value of an asset. Now, in some cases, there are industry values set by some consortium and so on. So they will set the price. Actually, crude oil is a good example where the price is actually set by OPEC at least, and everyone sort of like forms a consortium, and they all agree to sort of at least they set the production, the supply part of it, which has an effect on the price. The price itself is traded, but there's an effect on it. In some other industries, there is some standards that they set for prices and so on. Okay, now what are the factors of assets? So, for example, if you're going to buy a car, there are used car magazine reviews and so on, but there's also like a valuation guide like Kelley Blue Book or Consumer Guide, which says for this car and this condition for this year, so 2017 Mercedes-Benz C300 will roughly cost this much. If it's in mint condition, it'll cost maybe $30,000, and then in average good condition 25, and average condition 20, and poor condition maybe 15. So they'll have this kind of like a pricing range, which gives you an idea how much you should be paying for it. And then sometimes it depends on the provenance of the asset, like where did it come from? So in the diamond example I'm going to show you, provenance is very important, because sometimes there are blood diamonds, conflict diamonds, which are frowned upon by the consumers. They don't want to buy diamonds from a source which is funding some war or something like that, which they don't believe in. So that matters where it came from. So the same item coming from different places might actually hold a different value. And then authenticity is in some cases, in some industry, very important. And actually, one of the things that I'm focusing on in the industry is counterfeiting. So what happens is, if you look at auto parts itself, there's a huge problem counterfeiting, and $500 billion industry just on auto part counterfeiting. So counterfeiting is becoming a headache, and its overall market is about $2.8 trillion today. Oh no, 1.8 trillion is going to about $5 trillion. So it's a very, very big market. Impacts luxury goods, alcohol, liquor products, handbags, some clothing, but mainly on the high end for the luxury items, and then watches, and then parts like plane parts, car parts, things like that. That's the issue that impacts the value. Ownership history, like the same vehicle has changed hands 3-4 times. It might have a lower value than a car which is first hand owned by a single owner. And then the grade, like what grade? Like we see that in diamonds, like color, cut, clarity, carats, but we also see that in oil, like in gasoline, which is 87, 89, 91 octane. So the higher the octane, the better, the more you pay for it, and so on. Now, the ownership of assets, one of the problems, like I said earlier, with some of these asset classes, it's not governed properly, in the sense that it's nobody has a record of it, and that's one of the issues that blockchain can help solve. In fact, as a personal example, in certain countries, land ownership and land deeds are being put into blockchain because the city records and so on are kind of a bit untrustworthy. And so this is a personal example for me, where I've got some ancestral property in India that is under some sort of dispute, and so it's stuck in the courts because the title for that particular asset is not very clear when it changed hands, or if it was sold in an unauthorized manner and things like that. And that happens quite often in some of these developing countries or third world countries and so on. What's happening is someone might kind of squat on your ground and say it's mine, and then what are you going to do? And you have to prove. And if the records are kind of fudged or not trustworthy, then it calls into question the ownership history. That becomes a big problem. Like I said, authenticity also matters. I'll tell you just one quick anecdote on this, which is when you talk about this auto parts. So let's say a car manufacturer gives to a supplier, let's say $1 million to go and produce 10,000 parts of some kind. What happens quite a lot of times is it's not like someone is knocking off the part in some illegitimate factory. The legitimate factory itself, instead of producing 10,000, they produce 11,000, 10,000 for the OEM, and then 1,000 like a gray market that they float in the market. And that's sort of like it has the same quality most of the time because coming out of the same assembly line, but it's counterfeit because it's not authorized. And so those are the types of things which are very hard to catch. So this is something that, again, blockchain along with edge computing can help solve to a certain extent. And then provenance, like we said, it's a lot of products currently there's no traceability. And so in the food industry, for example, more and more consumers are asking for it. Where did this come from? If I'm eating something that is safe and I want to know about it. And so a lot of manufacturers in the consumer products goods market are starting to put where it came from, or at least a QR code you can scan and you can figure out where it came from. So now, like I said, the asset types, there are 4 types that we look at and objects, and there might be others, but at least these are 4 main ones. Digital assets. So a lot of you have heard about NFTs and things like that in the market, and that's something that is becoming much in vogue, because what people are starting to see is I can take any sort of illiquid asset and create liquidity for it by using tokens, and we'll cover that area in a bit in a couple of slides. But so digital assets are like things like video, audio, avatars in games and things like that. Those are one class of assets. Second class of assets are physical assets. So it could be a fleet of vehicles, it could be containers for shipping and stuff like that. And then dynamic assets are assets where you have to measure, like carbon emissions, water, energy, and so on. They are flowing, they are hot, or in the case of electricity, you cannot hold it. You have to measure it. Then only you know how many kilowatts is produced. Like I've got like some solar panels in my backyard which produce a certain number of kilowatts, and some I use for the home, and the rest I sell to the grid. And so I need to know how much is produced, how much I use, and then the balance I sell, and then how much I receive. So in order to do that, I have to quantify it. Now, what happens is these three classes of assets are many other things you see around your home, in your daily lives, and so on. Now, with blockchain, what happens is you can now convert into financial assets. So basically, you're taking one of these types of assets and saying, okay, now I can convert it into something that's tradable. And that's where the tokenization aspect becomes very interesting. And then you can have some of this logic that governs that tokenization be embedded in smart contracts or parametric contracts. So, for instance, we have a client in Houston, and they're an oil company, and they pump. They are actually like an oil services company. I'd say they make a flow meter, and a flow meter is present at the oil head, well head, and then to wherever it needs to be pumped. Let's say to a refinery. So what happens is there is at the wellhead, you put one flow meter, at the other end, you put another flow meter, and you say, okay, I'm going to ship 1,000 cubic feet of oil from point A to point B, or at least that's what I'm attempting to do. But oil is a very capricious asset because it can evaporate, it can leak, it can contract, it can expand. So by the time it reaches 1,000, might become 980 or something like that. And then the buyer is going to only pay for 980. And also in the same time, the price of crude might have fluctuated significantly. If it's a few cents, that might be okay. But if it fluctuates like $2-3 a barrel, then you got a problem. So both parties might say, okay, if it fluctuates so much, I'm going to pay you whatever we agreed plus some fraction of the prevailing rate plus minus into a formula, and that formula can be captured in a parametric contract. And then when the oil reaches from point A to point B, the buyer pays the seller automatically through a smart contract, which can trigger payments and so on, without having to haggle and send an invoice and all that kind of jazz. So you can take a lot of business logic and embody it in a smart contract. So those are types of things that we are beginning to see with these asset classes, because it's not just tokenization, but it's actually the business logic that governs the token is also built in. So now, just for those who are not familiar with blockchain, just a quick few slides. I'm not going to bore you with the details here. So, on the left side, you see these centralized ledgers. Whenever you're tracking things, you can track things in your own database and centralized ledgers and so on. So this is the current status quo. Like, for example, if you put money in a bank, that bank knows that John Doe has $10,000 in the bank. So that's maintained within that bank system. Not in other bank system, nobody else knows it, but only that bank has that record. And so when you go online and log in and so on, you'll say, okay, John Doe, I've got $10,000, like that. Now, what happens is when you go into a distributed ledger system, like let's say in Ethereum or something like that, the whole world knows, all the Ethereum nodes hold the data, and the whole world knows, okay, John Doe has got 10, this wallet is received this amount of tokens, or it sent this amount of tokens and on this date and time. So what happens is it becomes public record. It's decentralized. It's supposed to be centralized within an organization. Now, the main thing that the folks who are in the decentralized camp like about all these things is there's data is not being maintained by one entity, and sometimes that leads to abuse. So we started to see some of this news, and I'm not going to take sides on this, but some of the social media companies out there, they're always in front of Congress trying to prove that they're not abusing the data that they're collecting. Like, big companies like Google or Facebook, they're collecting a lot of data, and sometimes there's a lot of feeling that it's being misused and for their own profit, but not sharing with anyone, and it's kind of using the public at large. And so the decentralized folks tend to fall in the area where they say, data has to be transparent. You cannot use it for your own purposes, and no one sort of owns the data. It's shared. It's like in the commons, shared by everyone. And so distributed ledgers are the way to go. Now, one of the kind of like a little bit of a small confusion that happens is people kind of use the word distributed ledger technology and blockchain synonymously. So that is like saying, the only type of aircraft is a helicopter, but that's not true. That there are propeller planes, there are jet planes, there are rockets, there are different types of things which can be classified as aircraft. Now, so what happens is same thing in distributed ledger technology. There is directed acyclic graph, like a project like Hedera Hashgraph or IOTA, and then there are blockchain, which is like Bitcoin and Ethereum and others who are using that technology. Blockchain looks like a long list of like a linked list or a bunch of rail cars strung together, and these acyclic graphs look like a tree structure. So this is the picture for it. Acyclic graphs tends to look like a network architecture, and then blockchain looks like almost like a string of rail cars are strung along together. Now, what do these distributed ledgers carry? They carry, I think, three things that I look for. They carry the data, obviously. Data is being written to some decentralized place. They are a network, because now we got a bunch of nodes that hold this data. And then there's logic, like I mentioned earlier with smart contracts, holding the logic that works on the data within the blockchain. When the logic needs to get data from outside the blockchain, that's where you use something called an oracle. Like if you look at projects like Chainlink and so on, those are oracles. That means they have to go and fetch the data. Let's say I want to go and fetch the prevailing price of crude oil from the NYMEX or something like that, or COMEX. I go and call an oracle, it'll go and fetch the data, come back, and then calculations happen within the smart contract. So anyway, now in terms of blockchain itself, there are many architectures, and it comes in many flavors. So let me just show you a picture. It's more easier to kind of like wrap your head around it. So first of all, the one that we all kind of like talk about daily is the permissionless or public blockchain, which is your Bitcoins and Ethereum and things like that. So those are like blockchains that anyone can sort of use, and you can ride on top of it by creating your own token and things like that. So that's the public chain. You don't need to host the nodes. The nodes are already held by different people, different organizations, and then they get rewarded for processing transactions. Now, in the permission ledger, this is more for consortiums where a bunch of companies are coming together to share information. And so in those cases, what happens is they have their own private group. It's like an intranet versus internet sort of like mindset. Now, there are also couple of other architectures. One is like hybrid architecture, where some of the information is in the public network and some of it is inside the private network. And then there are also federated architectures, where if you look at, I would say like things like Cosmos is a good example, where you can kind of bring heterogeneous ledgers together under one sort of like umbrella, and so you can move data between different ledgers through sort of a common substrate. Okay, now smart contracts are simply the way I look at it. I'm going to date myself and be a bit old school. So for those who are familiar with relational databases, there are what do you call it, stored procedures. So stored procedures are code that's embedded in the database that act on the data within the database. So I look at smart contracts as something similar. They're just code which is in the blockchain, which acts on the data that is being stored in a particular node. And so what happens is it's just logic that is very close to the data. And then these smart contracts can be coded in different flavors. So depending on the blockchain, like in the case of Ethereum, the language is Solidity. In the case of Algorand, that's one of the blockchains that my team uses quite often. It's Teal, which is like a Python variation. And so like this, different blockchains have got different underlying languages that they support for these smart contracts. Now, let's just move on. So tokens. So what are tokens? So tokens are, I would say that these are sort of exchange of value that one can create on top of a blockchain, and tokens can be created in, many blockchains support tokens, like Ethereum, obviously, and then Algorand, EOS, Solana, and so on. So, and then these tokens have got certain variations, like fungible tokens, non-fungible tokens, and semi-fungible tokens. And then also how they're classified as a security, utility, or payment. So let's talk about those two aspects. So what is fungible? Fungible means like the US dollar is fungible. So I've got a $1 bill, you got a $1 bill. If you swap the $1 bill, the serial number might be different, but the $1 bill can buy maybe not $1 in the case of Starbucks, maybe it's $5. So $5 bill, I can go and buy a cup of coffee at Starbucks because it's no longer $1. But anyway, my point is you can swap the dollar bills and still the same value. And that's fungible. But then when it comes to non-fungible tokens, it's a bit different. So for example, like if I tokenize my car and you tokenize your car, and your car might be bigger, nicer, and my car might be a rinky-dink old car. Now what happens is I cannot swap my token for your token because they represent different value under the hood. So and that's an example of non-fungible. So you cannot just quickly swap the tokens and things like that. Now, semi-fungible token slightly different. Okay, it's a kind of a hybrid. So, for example, if I give you like a $10 Amazon coupon, and you have a $10 Amazon coupon, and I have a $10 Amazon coupon. Now, what happens is I can give you my coupon, and you can give me your coupon, and they are fungible. You can swap, same value. But then what happens is now, let's say that you take that coupon and go and redeem it. So I buy something, a book with it, and then you go and buy a pen with it. Now, what happens is the book and the pen are now non-fungible. You cannot just swap those two because they have different value. The book, let's say over time, might lose value. Just, you'll see all the used books, so books lose value significantly. And then, especially if there are books with series and editions, like, you have edition 3, and then when edition 4 is published, edition 3's value drops significantly. Whereas the pen you bought might be something valuable and can hold its value, let's say. Now what happens is these two are not tradable with one another, it becomes non-fungible. So before it gets redeemed, it's fungible. After it gets redeemed, it becomes non-fungible. So that's what a semi-fungible token is. Okay, now how do we classify tokens? They can be security, they can be utility, or they can be payments. At least this is sort of the Security Exchange Commission definitions out there, and I don't think anything is written up, but this is the research says that this is how they classify. And it's very kind of like gray area actually, because there are tests. One of the tests they use is Howey test to figure out whether something is utility or security and so on. Because what the US government doesn't want to have happen is that regular average people buy these tokens thinking that they'll appreciate or whatnot and then lose their life savings and things like that. They're trying to protect. So anyway, the tests are like whether you're security, utility, or payment. So whenever you are a security, it's usually meant for used as an investment. It's an investment token. It doesn't have much utility. And when we talk about utility, we're talking about how where all the token can be used. That's the word utility, right? Where can it be used? And so if it cannot be used quite widely, then it's a security. And then in some cases, tokens are used as payments, just for. So, for example, like if you have a tokenized form of a regular currency, fiat currency, that can be a utility token, and so on. And in some cases, like if I use a certain blockchain networks, like IPF is a good example. It's like utility. It's a utility. I use storage. I'm not holding on to a token for necessarily appreciation, but I have to use the storage. So that will be a kind of a utility. Okay. Now the tokens themselves have got value, and a lot of you, I'm sure, some of you have played the token market, bought and sold tokens and so on. And tokens value depends on 4 sort of like sort of cornerstones or pillars: velocity, utility, volatility, and liquidity. And these are like very similar to your economic theory of M1, M2, M3, money supply, and so on. And there are certain rules governing things. So let's just quickly look at a few things. If you have a lot of utility, then that means that token will be used a lot. There's many, Starbucks, let's say, starts accepting Ethereum or something like that. Then there'll be more use cases for that particular token. So you can go there, spend your Ethereum to get a cup of coffee or something like that. So now this and let's say a gas station takes it, and pharmacy takes it, and so on. So now you have many ways to use the token, and so circulation of token will be more widespread. So that'll increase the utility will tend to increase the velocity at the same time. If you have no utility, people are just going to hold it and hold and wait and hopefully that it appreciates and things like that. Now, now what happens is there is a kind of a formula that's in the space. So basically, the example is that let's say that the transactional activity of an economy is $100 billion, and the money supply circulates 10 times. And that means the value of the currency is 10 times 10 billion, which is $100 billion. But if the money money does not circulate 10 times, but money circulates 100 times, then the value of the money is only 1 billion. 1 billion times 100 equals 100 billion. So these are things that people launching tokens, they look at a part of something called tokenomics. So you cannot have something which is so lacks liquidity that what happens is when it lacks liquidity, it's just stagnant, and it also tends to create the lack of liquidity causes the velocity to go very low, and then when you try to sell it, you might have a big spread between ask and bid and ask, and so you might actually lose value. So you need to have some degree of velocity for that token. But at the same time, you don't want velocity to be so high, like people receive the token and immediately they convert it to fiat. That means the token, they don't believe in the value of token, or the token is fluctuating so crazily up and down that they don't know the value of it, so they immediately convert it to something which is stable, which they can use. So you don't want the volatility to be too high, you don't want the velocity to be too low, but it can't be sky high as well. You want velocity to be sort of people think that, okay, if I received the $10 from Joe, I can now go to Starbucks and buy a cup of coffee, so I can actually use it. Let me hold on to my pocket. I might not go to Starbucks today, I might go a couple of days from now. So I can hold it. I'm not going to sell it immediately. So those are the types of things that enter into this tokenomics. Okay, now tokenization itself. What are the benefits of tokenization? Liquidity. So if I take an illiquid asset and start to tokenize it, we are beginning to see that in the NFT market. So some piece of art, which is, if you don't do anything, the piece of art is just hanging on your wall. So now you want to sell it. Now what happens is if you tokenize it, the chances of it being purchased is higher, and we are starting to see that already. Like, we have a customer in the diamond market. We've got about $6 billion worth of diamonds in the blockchain, about 1 million diamonds from 8 of the top 10 manufacturers, and selling it to eBay and things like that. So diamonds themselves are very illiquid. Unlike gold, which has got a price, standard price worldwide, diamonds are a little bit more subjective. Okay, the color, cut, clarity, and carats give you the determination of diamond, but they don't say whether they're owned, pre-owned, and things like that. And so also they don't tell you whether they're lab grown, or which is synthetic diamonds, or real diamonds that are mined. So what happens is you have to it becomes illiquid. So only way to create liquidity in diamond market is to go to a pawn shop, and that guy will give you, let's say, 20 cents, 30 cents on the dollar, which is not really what it's worth. So you want to create liquidity. So if you make it tradable, then people will pay sort of like what they believe is market rates. And so that way you'll get more of the cash out of the asset. The other thing is in some cases you can reduce the cost of transactions through disintermediation. So this is happening in the real estate tokenization. So real estate brokers, at least in the US, they take 3% on the buy side, 3% sell side, 6% for the transaction. But if the buyer and seller can sort of disintermediate and meet each other in a marketplace, then what happens is that cost drops. The marketplace might take maybe a certain percentage, 1% or whatever it is, but it's better than paying 6%. So buyers and sellers can sort of like have a marketplace where even the market making the matching between buyers and sellers could happen through automated market making. The smart contract is acting like the sort of matchmaker. And then transparency is also another benefit of tokens. You can start to have the provenance, like who bought, who sold, when it transferred. All of that is recorded on blockchain. Like, for example, Ethereum, like I said, or any of these things, you can go into a block explorer and go and see what happened with each account, where did it move, and things of that nature. So you can see, and that transparency is important in certain cases like anti-money laundering and so on and so forth. Now, the other thing that it does is like in certain asset classes, it creates fractionalization. So you can create accessibility. So for example, let's say a Bugatti car is about $5 million, let's say. So average people love to drive a Bugatti sports car, but they cannot own it. Now, if you fractionalize the ownership of that car, that 50 people can each put a certain amount, 100,000 each, and own a $5 million car. And the accessibility might be much bigger. Or if 500 people, for $10,000, 500 people can own the Bugatti, then they can fractionally own it or even have chances to drive it once in a while. Then what happens is it becomes interesting. The real use case happening in the real estate market where people are starting to fractionalize real estate. So if you're coming out of college, you have a choice of renting a house or buying a house. Now, most people are starting to say, hey, you know what? I don't need to rent. I can buy, but I don't have the down payment. I don't have what it takes. Let me just own a fraction with 3 other roommates. It's better than paying rent for a few years. And until I get up to speed and have my savings, I can then go off and buy my own house. But until then, at least I have a fractional piece of something. So that's changing the kind of like the rental market completely on its head. Also, what are the opportunities created by asset tokenization? You have disintermediation, and that's in the music industry. A lot of people always complain that they're not getting their fair share of the revenue. So that is changing quite rapidly. In the energy sector, so there's this whole movement about distributed energy resources. So the energy grid companies, right, they used to produce all the energy in the world, but nowadays people can produce energy on their own through wind, hydro, solar. And so those energy, like I'm an energy producer myself. So what happens, if I tokenize, I can now sell that energy to other people. And so that empowers me as a producer of energy. I can sell it back to the grid as well. So what are the key takeaways? It disintermediates, it democratizes and decentralizes all these asset infrastructures, makes it more open and transparent. So how do I trade these tokens? So tokens themselves are stored in wallets. And these wallets, there are 2 broad categories of wallets, custodial and non-custodial wallets. So if you go to a Coinbase or a Kraken or some exchange, they usually have their own wallet. That's a custodial wallet. But then for those of you in the crypto market that you go between sites and so on, you want to hold on to your own assets in a wallet, you have a non-custodial wallet. That is, the wallet belongs to you. So if you go to a bank, for example, mobile banking, you see, okay, John Doe has got $10,000 in the bank account. That's a custodial sort of wallet or account that is maintained by the bank. You are not taking that with you. Whereas in the blockchain world, there are these 2 concepts. Like custodial means they maintain it, and non-custodial means you maintain it. So when you maintain, you have to remember the keys and seeds and all that. If you lose that, too bad. Then you lose your tokens, which a lot of people who are new to this need to remember. So these are 2 sort of separations out there. And then how do you trade these tokens? You can trade them directly. So you can go to your friend and swap tokens. There are ways to do that. You can go to, you just need to know his address, and you can send the tokens from, let's say, a custodial wallet, non-custodial wallet like MetaMask. You can move it to his wallet and vice versa. Then in the centralized exchanges, you can go and sell your tokens to other people. You can also go to decentralized exchanges like Uniswap, PancakeSwap, and so on, and go and sell these tokens. You can also see these, what do you call it? In the case of non-fungible tokens, websites like OpenSea, Rarible, and so on, they're selling tokenized versions of certain assets like videos, NBA videos, and this and that, and art, and so on, so that you can go and buy these tokens from these, what do you call it, storefronts. And then and also some of them support marketplaces where you can trade, secondary marketplace, you can trade with other people. Okay, now how do we price tokens? Tokens can be priced in a number of ways. Fixed price is the most common one that you see in most places, but that does not mean that, if you see a lot of ICOs and so on, you have time based. Like if you are the first investors, you get it at a discount. and then they have tranches, and the discounts start to disappear as it goes to the open market. So some people get tokens at a very low price, and then when it goes to market, they can sell it for a profit. So there is time-based pricing. There is auction-based pricing, and that's becoming slightly more popular in the NFT space for artwork and things like that. Like Sotheby's is doing a virtualized event on Decentraland Metaverse, and that's going to be more auction-based, obviously. And then dynamic pricing. You can have like a logarithmic curve of some sort, or exponential curve, or whatever curve that you wish to say, set up. In this particular example, like a piece of art, there's only 10 printed, let's say. And the first pieces sell for $100. And then by the time the last piece is left, it's sold for $5,000. So this kind of tiered model can be put into your smart contracts. And then market pricing, obviously, like tokens that are traded, they have a market price that's set by just the demand and supply, and that's there. And then tethered pricing, like CBDCs, the central bank digital currencies, or your USDT, like Tether, and you have USDC. Which all tethered to the US dollar, and there are also tethered tokens being started for other currencies and so on. These are pegged at one to one usually. Okay, use cases. This last couple of slides here. So a diamond market, like I mentioned before, very illiquid market, controlled by a very small handful of companies. And so we have a customer called Gem Identity as a partner, and we have a ownership interest in this as well. But we have a blockchain ownership history that we maintain. We also know where the color cut, all the GIA certificate things are in the blockchain. But every diamond has got a laser inscription inside the diamond. And so what happens is the laser inscription matches the GIA certificate, and we also maintain the ownership history to say, okay, Jane Doe owns this diamond. If she wants to sell it, then the new owner's name is also recorded. So you know if it's first hand or not. Just for record, 40% of all diamonds in retail in America are used diamonds. Whether people got divorced or it's an estate sale or someone died or whatnot. Then it's returned to the retail guys, and they polish it and resell it, and without telling you that it's not a new diamond. So knowing that might change your opinion on whether you want to own it or buy something which is genuinely new, and so on. So this area, total lack of transparency, we are bringing a lot of transparency, and and creating the ownership history. So if the diamond is lost, you can also, for your insurance purposes, it becomes pretty easy then. Okay, then in the case of media industry, there is marketplaces that are evolving. For example, your playlist is no longer a personal thing. You not only share it, but you can sell your playlist, let's say. And in other areas, like in AI and so on, people are beginning to sell data. They have data that is used for training sets or and so on. They're selling that training set data to other people so that they can use it to train their AI model. So data of any sort can be sold. That's something to think about. And then final example is energy tokenization, which I've covered a couple of times before, which is you have this renewable energy credits from wind, hydro, solar, that you can then take the data from the smart meter. In some cases, people who have got the alternator to store, like a big battery to store the energy that they produce, then they can sell it through microgrids to their neighbors or whatnot. And in my case, for example, it's not like that. I don't store the energy, but I immediately push it out to the grid. But then in the US, we are not tokenizing, but in other countries, they're tokenizing this energy. And then the holder of the energy can then sell that clean energy to people who want to purchase the clean energy credits for to be carbon neutral. So if I use a lot of energy and I'm using dirty energy, I want to get some carbon credits from the government. I buy your carbon, your clean energy credits to offset my dirty energy, and then I get some rebate from the government and things like that. So people are doing all kinds of models like this. Okay, so that was my sort of like coverage of asset tokenization. Hopefully, it gave you something to think about, and thank you for the opportunity.
All right, thanks, Raghu. That was great and very informative. Yeah, so I'll now ask the attendees to post their questions on Slack or on the YouTube chat. I have one question based on your slide on the diamonds. So there you mentioned that there is an inscription on the diamond, and that helps one to verify the authenticity, meaning that you go and check it, and then you cross-check it with the record on the blockchain and you verify it. So it's somewhat reliable for diamonds, but for other assets, like data or some other things, or even energy, I don't think it's that straightforward. So are there any mechanisms to ensure authenticity for some of these harder to track assets?
Yeah, so there are attempts being made, like in some industry easy, like like in car industry, you have VIN number. Yeah, that's one way to track it. But then like energy and so on, you'll probably have to add the smart meter number. And then what happened was, we actually worked with the Spanish energy company called Iberdrola. And Iberdrola told us one of the problems that they're facing is people are claiming that they're creating solar energy at night. So what has to happen is, you cannot just take the data from smart meter and claim that it's real. What you have to do is run it through some AI algorithms. Or another one might be a little bit more insidious. It might be daytime actually. But then, if you take the weather data and you munge it with the data and you see, yeah, you know what, that day was like cloudy and raining and very dark. How did you manage to produce 10 kilowatts of energy? It's impossible. So you have to use AI to kind of say, you know what, this I'm not going to give you full credit for this data, because you claim you're 10 kilowatts, I'm going to give you only 2 kilowatts, let's say. So there are those types of things to validate the data. And what we have to do is to attach like the smart meter number or something to it to authenticate. So that's the last mile problem, right? So there's an article from HBR, Harvard Business Review, called "What Blockchain Can't Do." So that's where IoT comes in. So whenever you have to grab data from the field, you have to attach something that proves its authenticity. But we also, along the way, in the transmission of data, you have to encrypt it and so on. So you don't have man in the middle attack to kind of fudge the data or something like that. It has to come from edge to blockchain in a pristine manner, end to end. So things like that. But yeah, it's a case by case basis. We have to see what all we can do to ensure. Like, property is very easy. You have a title, a deed number, and things like that. So it depends on the asset class actually. So, and also you can do things like in NFT and so on. You can do like a watermark. You can put a watermark, like an invisible watermark, one layer, to kind of like make it different from other fake assets. Like someone just taking a video of the or a picture of it may not get the watermark, whereas the real one might have layers, things like that.
All right. And also, yeah, you briefly touched on the IoT and asset tokenization in that context. So are you aware of any real world, use cases or even applications that employ tokenization in the IoT context?
I mean, there are companies beginning to do that. I mean, they are doing it, like VeChain, for example, is a good example. They are tokenizing, I think, liquor bottles and some luxury items, and they are putting tags like NFC tags or other types of tags on the edge. Whether you want to call this is IoT, that's questionable. But I think Helium is another one, which is doing crowdsourcing connectivity. So they are like a LP WAN provider. So they are doing like a LoRa network. So what happens is they ship you a LoRa box, and so every time the traffic goes through your box, you get a token. Okay. So that means, you understand what I'm saying? So same thing you can do with even air quality monitoring. So for example, like, you crowdsource air quality monitoring. So you buy the equipment from the whoever, and then every time your machine is called upon to provide data for air quality. So the consumers might get a free app, and then when they look for the air quality reading, like particles per metric ton or whatever it is in your area, they might actually hit your server, your box, and then you get a payment out of that. So like that, crowdsourcing data. So.
All right. Thank you. And do we have any other questions from the attendees? Right. If not, thank you once again, Raghu, for
Sure.
informative talk. And yeah, it's going to be available on YouTube for others to check out as well. So I'm sure people will appreciate the information that you shared today.
Thank you. Thanks for
Right.
having me.
All right. Thank you. And that brings us to the end of BlockSys 2021. And I would like to take this opportunity to thank the local organization members. A special thanks to Marcelo for running the Zoom session today, from the morning, and also Vasco for helping us, with information for Zoom and also for Slack. And also we would like to thank the publication chairs, Rita and Lucia, for their support during the publication phase, because we identified a few issues, and yeah, they really helped us overcome those issues during the publication phase. And I hope the attendees enjoyed their talks today. And like I said, all the talks are available in YouTube for you to check out in the future. And yeah, we hope to have the BlockSys next year as well as part of Sensys. And until then, and goodbye from the BlockSys organization committee. Thank you all. Bye.